that you can sign up to receive automatically, and that will provide ongoing updates on the EHS projects as well. So with that, I'd like to conclude the introductory presentation, and we will move to the first or the next speaker on the agenda, which is Andrea Richards from the JRC, and Andrea will be providing an overview of current IATA guidance. And so we're just, I think Andrea will be sharing her screen, so she's just in the process of doing that, and I'll turn the mic over to her.
Hello, this is Andrea from the JRC in ISPRA. I hope you can all hear me and see the slide at the moment. So good afternoon, good morning, or good evening, wherever you are in the world.
Hello, Andrea. Please, on the top menu, click on Share, then Application, to share the presentation with us.
I'm sorry, yeah, I was meant to do
Perfect, it's uploading.
Yeah,
and
okay.
Full screen view, perfect, thank you so much.
Right, I was concentrating on opening the microphone. So now we should all have audio and video. And yes, I try to give an overview of guidance related to IATA and IATA components. So the aim of the presentation is to show what is available, and in particular if there are any concrete reporting templates available with the guidance, and if they are including any statements about the assessment and reporting of uncertainty. And then from there we can make some conclusions and possibly discuss any further needs for additional guidance. Let's start by the IATA figure as well. I've just changed a bit the colors because of the kind of color scheme I've introduced for the different levels of guidance we have, and we have divided the available guidance into. So we have the overall IATA framework for hazard identification, as Eva already explained, and this is based on multiple information sources, either individual or combinations thereof, such as defined approaches, and they are all integrated and weighted to make a conclusion. And at the end, the conclusion will inform regulatory decision making and risk management, etc. So the overview of guidance includes different types of documents. For example, official guidance documents from the OECD, regulatory documents also from the World Health Organization, the European Chemicals Agency, ECHA, the European Food Safety Agency, or US EPA. This can be the official test guidelines or reports and related guidance documents. But there are also some selected papers from the scientific literature which do give some guidance or describe approaches related to describing methods or reporting, etc. And this is a big table overall, and in this presentation cannot go on all the details. I will show some examples of the different types of guidance to give the overall picture and see what is covering the different steps and levels of an IATA. And just also to mention different initiatives which are dealing with integrated safety assessment approaches. So obviously there's the IATA work at the OECD, especially also the case studies project, or also the ECMAS group and the IOP development program. But a bit more outside or different going on in parallel, there are other initiatives which we should also be aware of. So for example, the International Cooperation on Cosmetics Regulation, ICCR, as a working group on integrated strategies for safety assessment for cosmetics ingredients, using only new approach methodologies, NAM. And They have established 9 principles for the safety assessment, which have been published recently, and working on more guidance, like samples, along a integrated safety assessment workflow, which is still ongoing work. Or similarly, the research initiative Syriad has worked on a chemical safety assessment work for integrating different types of data to make a conclusion at the end. Or there's, for example, also a in silico toxicology protocol consortium, including more than 45 members from regulatory agencies or industry, academia, etc. And they're looking at also providing a more guided workflow how to integrate in silico and other considerations in the weight of evidence. And this is ongoing work and will be published as an overall protocol and for different endpoints. So just to mention some of the safety assessment initiatives apart from IATA as such. So again, to give this overview of different levels of guidance, we have overall the IATA concept, the general framework, which is informed by adverse outcome pathways, which, because the IATA should be mechanistically based, so IOP can give any indications which components to include. And then all the different methods and approaches as individual IATA components, as we have seen already, can also be defined approaches combining methods. And there are some overarching issues, for example, data reporting, data quality, or methods quality, where there's guidance for. And this first concerns mostly hazard assessment, but we could also look at exposure and ADME properties, so the toxicokinetic side, to have a risk assessment at the end. There would be separate guidance for these models. And then there's the integration step, the weight of evidence. Again, there's an overarching issue about uncertainty at all the different levels, the method and the weight of evidence integration, and then at the end, the conclusion and the decision making. And taking into account the data quality, uncertainty, etc., if this is well addressed, there's more confidence in the decision at the end. So according to these different levels, which are also a bit corresponding to the information to knowledge pyramid kind of comparison of levels, there are these major blocks which are introduced in the table, the collated guidance, and the information collected for of the different documents, guidance, obviously the title, then sector, organization, region, what is the purpose of this specific document or project, how does it link to IATA, which level or which step of the IATA does it belong to, the nature of the guidance, if a template is included, if uncertainty evaluation is included, types of uncertainty, and if there are scoring systems, either qualitative or quantitative. So all these information bits have been collected. And I'm going to show now some examples. So this is the overarching IATA framework guidance level. And the first thing we see, there's not really an overarching guidance for IATA. So I've put here the guidance for the defined approaches, which Sylvia will present later on, which are more components of an IATA, but they include introduction, general introduction to the IATA, so some guidance can be taken from there. And also the IATA case studies project has created a template for the IATA case studies with different building blocks that are meant to be flexible to build the IATA depending on the purpose and regulatory need. And then there's also the document for the use of AOPs within IATA, which could be mentioned at this general level. giving some indication mostly about how to use AOP for developing IATA. And then if we go at the component level of the IATA, for example, grouping and read across, there's plenty of guidance available. There's some overarching or high-level guidance, for example, OECD guidance, European Chemicals Agency guidance in relation to REACH, with some examples as well, different types of documents. There's an easy talk report about category approaches, read across and QSAR. And more concrete level, there's the ECA read across assessment framework RAP, which is a structured guidance on how to evaluate the confidence read across prediction. So it's about uncertainties, and there are also scores on this guidance. And also the IATA case studies project has developed a specific template for read across with more details and some tips how to present the read across argumentation. So there are several guidance available, and if you go into the scientific literature, there's even more. There's more concrete approaches about how to report and structure read across prediction. There are some templates, or in the Schultz paper or on the Blackburn paper, there are also some scores proposed, or decision tree, etc. So there are some indications and even templates available. And if we go to a different component of IATA, this is more a newer technology, or at least there's not so much guidance on a general available. There are many initiatives originally how to define the minimum information for microarray gene expression experience, for example, or minimum reporting standards for data analysis and metabolomics, etc., or some framework on the quality assurance of omics technologies. So there are several frameworks more at the technical level, let's say. But there was no guidance yet on a more regulatory level to include this in risk assessment, regulatory risk assessment. So at the moment, the project has started at the OECD about looking at transcriptomics reporting framework, and in parallel, there's the EasyTalk metabolomic standards initiative, which will then kind of merge with the OECD project later to feed into the metabolomics reporting framework. So this is guidance in the process of being developed. And looking at more overarching issues about generally reporting and data quality, there have been different initiatives. For example, the gold standard publication checklist or the ARRIVE guidelines, and how to report results of animal tests to make most of the information gained, and at least don't lose any important information if you carry out these tests. And on the other hand, there are the OECD harmonized templates, which for different endpoints, also physicochemical properties, mostly in vivo endpoints, which correspond to specific OECD test guidelines. And these are aimed more at developing database systems and enable electronic exchange. So these are directly feeding into the Euclid format, which is then a standard format to exchange information on this level. And as I said, the first, or most of the harmonized templates were linked to in vivo assays, and then with more in vitro tests coming available, there was a need to also report appropriately these new methods and test results. And for this purpose, the harmonized template 201 has been developed for intermediate effects, and the plan is to actually extend this and have a overarching template for all in vitro tests which are coming up, which will even more simplify exchange and standardization. Or examples for method, quality method, description, etc. There has been obviously long movement defining good laboratory practice, good scientific practice, or for example, specifically guidance on a good cell culture practice. This is important to actually rely on the data and have good methods adequately carried out. And there's the current new guidance about good in vitro method practice, again, to give more guidance on this new method and practices. And can also be, the OECD guidance document describing a non-guideline in vitro test methods. It's quite important because it allows to report all the methods which are not described by other OECD test guideline methods, which are not listed all here because there are many, obviously. But this non-guideline in vitro test methods is becoming more important, and it's actually linked also to the JRC database, DVALM, which stores online descriptions of methods. So it's useful to share descriptive methods and link to it from when reporting data to have a standardized method description available. Some other issues about data reliability or validity. Obviously, there's the validation of new test methods, and your ECVAM is obviously involved in this. And there's, for example, a test submission template available for reporting these new tests for validation. And it has listed here also the new project performance-based test guideline on defined approaches that my colleague Silva will explain more later on. And just generally, there are many different systems about assessing reliability of studies. So from the scientific literature, we find the chemistry scores, there's the toxicological data reliability assessment tool, which has a template, an Excel-based questionnaire to go systematically through and define the reliability of studies. Also defines a risk assessment and policy, share-up method, or general framework, for example, on relevance and reliability of experiment data described by Kaltenhäuser et al., which includes some tables and checklists. So again, there are some different systems available. The Flemish one is obviously kind of a standard for in vivo tests, but it depends on the data you look at. And this leads to the also overarching topic of uncertainty. So these are quite general frameworks about uncertainty assessment and reporting from different agencies or institutions. So use EPA, again, the ECHA guidance related to the REACH legislation. There's also WHO, International Program on Chemical Safety guidance document on evaluating uncertainty and hazard characterization. There's also documents for exposure assessment and uncertainty. The EFSA has a new guidance which is still in draft status for some time. It's quite comprehensive and very detailed and meant to be very flexible and adapt to different needs. And probably this will be released by end of the year, I think. And there's also the EFSA guidance on the assessment of the biological relevance of data and scientific assessments. So again, there are major guidance documents available. And at the more specific level, guidance on uncertainty assessment is given in specific guidances. So as mentioned before, the guidance document on the reporting of defined approaches within IATA as a principle 6 on consideration of uncertainties, and some guidance how to describe and how to deal with that. And for reader cost, for example, as already mentioned, there are some concrete guidance or structured assessment, for example, in ECHA with assessment guidance and scores actually for the confidence of the prediction. And moving on to the overall weight of evidence, which should bring together and weight all the different data streams we have seen before. There's not so much concrete guidance maybe available. There are some important documents, again, from WHO, ECHA, and EFSA, or also in the scientific literature. But there's an ongoing current OECD project to define the guiding principles for establishing weight of evidence for chemical assessment, which should give more principles and concrete guidance for harmonization of weight of evidence. So looking at all these different examples, we see that actually many guidance documents are available and at different levels related to IATA. But one gap, or the first gap maybe, is as no general IATA guidance as such. Maybe giving, again, a concrete definition of all possible IATA data sources, which are mentioned in the defined approaches guidance, but maybe this could be more explicit with some guiding comments on the different methods, for example. We have also seen that our guidance documents include templates or concrete framework workflows, which are actually quite useful tools. They're user-friendly and also support standardization and harmonization of the approaches and the reporting. The next type of gaps, maybe look at all these guidance available. We could think maybe there are even too many different guidance and quite confusing, different levels, types, and details given, and actually the more concrete guidance are more at the lower, let's say, technical level. So the gap or the need maybe would be how to bring all these different guidance approaches together, different levels of different legislations, etc. And if there are several options, do we need to choose one specific one for standardization in the global sense of regulatory assessment? Or how can we compare them? Or are they interoperable, so we can just take building blocks and add them all together? So there might be some need for more integration and harmonization, or maybe even some kind of standardization if the aim was to have a universal scoring system which would fit for different method sample. And another issue is the mutual acceptance of data, so the acceptance of the test results globally without repeating the essays for different legislations. And generally, information generated by some IATA components are covered by the mutual acceptance of data, but the final decision, if it's not a defined approach, it's not covered. So unlike test guidelines, the whole IATA may fall outside the scope of the mutual acceptance of data. The gap or need would be how to guarantee global acceptance of non-animal predictions in the context of IATA to actually promote or facilitate the use of these new methods especially. And we know that there's no one IATA fits all, depends on the endpoint and on the regulatory purpose, etc. So the IATA has still to be flexible. So as Eva has already shown, there's this contradiction between prescriptiveness and flexibility. So overall, some harmonization across countries and probably also sectors would be needed in terms of guidance. So some issue for discussion would be, for example, would it be possible to create an overarching framework into which you could kind of anchor all the individual guidances to promote harmonization, etc. So these are just my thoughts from the mapping exercises. Yeah, it has all to be discussed. And I think to begin with, it is important to actually be aware of all the approaches and initiatives and guidance which are out there. And yeah, if you have them all, maybe it's possible to create a kind of one-stop reference point from where at least you can link to all the available guidance, initiatives, and documents and templates, etc. So either in a document or maybe from a website portal, so at least everybody has an overview of what is available and what can be combined or what exists at the same level, etc. But then probably also some concrete guidance would be needed and actually apply all these different bits and pieces of guidance in the context of the IATA. And for this, some concrete examples or case studies as they are being carried out in the case study project would be quite helpful. And then generally, the relevance of all the information that has to be methods and approaches have to be identified depending on the regulatory purpose and at the end the protection goal you're looking at to solve or to use the IATA for. So there are many questions, but I think there are many documents as a big basis, broad basis, which everybody can use. It's just a matter maybe of organization and harmonization. So I think it's important to keep up disseminating and being aware of everybody else's ongoing projects, as we do now on this seminar, and keep the discussion ongoing. Thank you.
Thank you very much, Andrea, for the presentation. I think it's great that you're doing this mapping to help us all understand where there is available guidance documents and where some of the gaps are and how we might be able to move forward to address some of those gaps. So as we move through the next few presentations, I also invite anybody who has a question or maybe comments for Andrea to type them in the chat to me, Eva Leinala, in the chat function. So I think some of the things that Andrea raised were, are there too many levels of guidance, and how do we bring these together? How can we guarantee global acceptance of non-animal methods? Is it possible to create some type of overarching framework where these various guidance documents feed into? Should we create a one-stop reference point? And also how to identify the relevance to regulatory purposes for some of these guidance documents. So I'm not going to ask Andrea any questions right now, but please, if you have a question, to send it in via the chat. So I think, thank you, Andrea, and we'll come back to you for questions, and we'll move directly to Sylvia's presentation. So next we have Sylvia Casati, also from the JRC, and she has two presentations. One is guidance documents on defined approaches, and then the next is performance-based test guidelines for defined approaches for skin sensitization. So Sylvia, over to you.
Thank you, Eva. Can you hear me?
Yes, we can hear you.
Perfect. So thank you for the introduction, and hello to all those who are listening to the presentations. Yes, I'm going to illustrate the two guidance documents on defined approaches. And before introducing the two guidance documents, I will provide a little bit of background to the development of these two documents, because this is important and informative also for the next presentation under agenda item 5. So we are talking about the area of skin sensitization, where we have seen much progress in recent years in the development, validation, and OECD adoption of non-animal testing methods. And this is mainly due to our knowledge about the mechanisms underlying these human health effects, which are captured by the OECD in the form of an adverse outcome pathway. So what you see in the slides, especially under the molecular initiating event and the cellular response, are the methods which are currently available in terms of methods which have been adopted by the OECD, and those are highlighted with the red square, and methods which are currently under consideration for adoption, and those are highlighted with the blue square, and gives us an indication that much has been done in this area in the development of non-animal methods, and that besides those which are reported in these slides, there are other under development by industries or research organizations. So the picture is quite complex, and we have different opportunities for now performing the assessment of the skin sensitization potential of chemicals, and by using a variety of methodologies. Now, if we consider the test methods which have been adopted and that I've presented in the previous slide, well, if we look into the test guideline, it is said that they cannot be used in isolation to conclude on the absence of skin sensitization potential, nor to assess skin sensitization potency. And the test guidelines prescribed that the data should be considered in the context of an IATA, basically in combination with other complementary information. But the test guidelines do not say what kind of information should be used to complement this data generated with the test guidelines currently adopted. So what happened is that industries, but also research organizations and other entities, started to combine the readouts from these methods into integrating approaches that you see here, a few examples on these slides, in order basically to enhance the predictive capacity, the accuracy in predicting the effects of interest, in this case, skin sensitization, with respect to the individual methods. And those approaches have been defined, as Eva correctly pointed out, as defined approaches by the OECD. Okay. Basically, here you have a sort of example. A defined approach could be either a sequential testing strategies or an integrated testing strategies. The difference between the two is that in the first case, basically, we have decision steps after running each individual method. And in the second case, we need to have multiple data at the same time to be able to integrate them using a specific data interpretation procedure. But what these approaches have in common is that they are fixed in terms of the data interpretation procedure applied to the data in order to derive a prediction, and they are also fixed in terms of the methods which are used within. So they are not flexible tools as IATA are, for example. And these approaches can be used on their own if they are able to fulfill a specific regulatory need, or they are envisaged as being used as components within IATA. By introducing the use of defined approaches as elements within IATA, we also improve and we standardize the way information is combined. So basically, we enhance the standardization of the IATA themselves. So in 2013, considering all the approaches that were emerging in the area of skin sensitization, the Joint Research Center, representing the European Commission, submitted a project proposal to the OECD for the definition of guidance documents for reporting these defined approaches. Because at that time, there were many approaches described in the scientific literature, but they were not consistently described. And so it was felt that it was important to have a structured and consistent approach to their documentation in order to facilitate their evaluation and application in the regulatory context. So the guidance for reporting defined approaches is intended to be used together with similar guidance, which is aimed at reporting other possible IATA components, such as QSARs and grouping and read-across strategies, as well as non-guideline in vitro methods. We have heard about these guidance documents from Andreas previously. Now, we talk about specifically two guidance documents. The first guidance is the OECD guidance document on the reporting of defined approaches to be used within IATA, which is the series on testing and assessment number 255. And this guidance provides principles for describing and applying defined approaches, provides template for reporting defined approaches, and template for reporting the individual information sources used within defined approaches, which are not reported elsewhere. Because, as I said before, this guideline is meant to complement also existing guidance on the reporting of other IATA components. So, in relation to the principles, so basically, those are principles that a defined approach should be associated with in order to be considered in the regulatory context. And the principles are explicit, so the defined approach should be associated with a defined endpoint. And in the case of the exercise we did within the working party of hazard assessment that was called at that time the Task Force on Hazard Assessment, the endpoint considered was skin sensitization. It was judged important to be explicit in the purpose of the defined approach, whether the defined approach, for example, could be used to satisfy a regulatory need, or whether the defined approach would be a component, a small component of a bigger assessment framework, such as an IATA. It was felt important that the underlying rationale, including the mechanistic basis for the construction of the approach, is well described. The individual information sources used within the approach should also be described. And there should be also a clear description of how the individual information sources are integrated. And as Andrea also presented before, there should be also some consideration about the known uncertainties associated to the construction and application of the defined approach. So these 6 principles were basically used to develop the reporting template for defined approaches. And you can say here this is structured into 11 sections. The first sections deal mainly with providing a concise overview of the approach so that people can get an understanding from the very beginning what the approach is dealing with. Then there are some general information about the author of the defined approach, for example, references to publication already available in the literature, the mentioning of any proprietary aspect linked to the use of the defined approach. We have seen that the endpoint addressed should be clearly described, as well as the purpose. For example, the proposed use of the defined approach, whether it is for screening purposes, for hazard assessment or characterization, for potency prediction, this should be clearly stated in the documentation. The rationale for its construction should be well defined. For example, there should be a clear description about the reason for the choice of the information sources and whether these information sources are linked to the known biological mechanisms. Because we might have also defined approaches which have been developed on the basis of a data-driven approach only, without considering the biological relevance. There should be a brief description of the individual information sources used within the approach, including the readouts measured, and also the process applied to derive the final prediction should be clearly described. And we have seen that there might be several possibilities for interpreting the data and integrating them. That might range from very simple approaches like the 2 out of 3 weight of evidence to, let's say, more complicated approaches like the Bayesian network or the machine learning approach. We also consider to make transparent the chemicals used to develop the approach and to test it, and to be explicit in the limitation and the strength in its application. For example, when we talk about limitation, we talk about technical constraints, or we talk about predictions which are wrong with respect to the reference data they are compared to. In relation to the predictive capacity, the request within the template is to clearly describe which are the misclassifications and the unreliable predictions, and to try to rationalize them to the extent possible. And as Andrea already mentioned, we also try to give consideration and weight in the template about the reporting of the known uncertainties related to the construction and the application of the approach. So the second template is the one for the individual information sources. This is a very slim template which is meant to provide an overview of each of the information sources which are used within, in order to complement the package without giving the person reviewing the approach the need to go into the scientific literature or elsewhere to find the necessary information for the evaluation. And this is what's in the first guidance document, in guidance document 255. One thing that I want to highlight is that although this guidance has been developed taking the skin sensitization area as a case study, actually the templates can be applied to the reporting of defined approaches developed in other areas. There is not yet experience with that, but it is envisaged that they can be used for reporting any kind of defined approach. Well, the templates that I've just illustrated have been used to document a number of defined approaches developed in the area of skin sensitization. And this is what is available in the series on testing and assessment number 256. And these case studies really provide guidance on the extent and level of reporting. Now, what you see here are the 12 case studies. It's an overview, basically, of the 12 case studies. Those which are highlighted in green are those which are suggested to be used for potency assessment, and those in blue are those which are proposed for hazard assessment. And we have mapped the information sources used within the different approaches according to the key events within the adverse outcome pathway. And as you can see, I mean, there is quite a good coverage of the molecular initiating event as well as of the key event 2 and key event 3. So, to summarize, the two guidance documents, 255 and 256, provide harmonized methodology for the reporting of IATA elements, as in this case, defined approaches. And this is considered to be a critical initial step to ensure consistency in the use of IATA-derived prediction and assessment for regulatory decision-making. We have two guidance documents currently on defined approaches. The first one provides guidance and templates for their reporting as one of the possible IATA elements, but we have also heard that in certain cases, defined approaches can constitute an IATA. OECD Guidance Document 256 provides examples on the application of the guidance and of the reporting template for defined approaches developed in the area of skin sensitization. One thing that is important to consider is that the case studies which are documented in the second guidance document do not imply any kind of acceptance or endorsement by the member countries of the OECD. They are simply intended to provide a perspective of how individual information sources and defined approaches should be reported. And also they provide a nice overview of the different forms this might take and the different regulatory purposes they might serve. So that's all for the presentation on the two guidance documents on defined approaches.
Thank you very much, Sylvia, for the very clear overview. And I do have some questions coming in for you on defined approaches, but we'll hold off on those until we hear from a couple more presenters. But I guess you are up next as well, and if we can move into the presentation on performance-based test guidelines for defined approaches for skin sensitization, and that might also address some of the questions.
Okay, perfect. Give me just the time to move to the next one.
Yes, no problem.
So I'm going now to talk about a project which is currently being discussed by the WNT, and which is somehow, let's say, the follow-up of the work that has been done on the reporting on defined approaches. So I just want to reiterate a few concepts because those are important. Okay, so the background, as I said before, is that the methods that are currently available in the area of skin sensitization when they're used in isolation, they cannot provide the same level of information as that provided by the current regulatory animal tests. And we have a number of defined approaches which are integrating data from these methods with other relevant information documented in a structured and consistent way. Nevertheless, we know that reporting it's an important first step towards international harmonization, but is not at all sufficient to guarantee the deployment of these methods and methodologies, nor acceptance of the predictions from defined approaches by the different regulatory bodies. So this is the premises for the project I'm going to talk about. Another thing that I wanted to highlight is that these approaches have been evaluated in different ways. We have information published in the scientific literature. We have few documents, including the one released by EUREL-ECVAM, showing some common features of these defined approaches. And we have also some activities ongoing in Europe and in the US, which are really directed towards understanding better how these approaches are performing in predicting the potential of chemicals to induce skin sensitization, and how well the predictions from these approaches relates to effects in humans. I'm not going to enter any detail about the performance of the different approaches, but I want to highlight some general features they have. So the majority of them have been developed and assessed with a substantial number of chemicals. So in certain cases, we are talking about more than 150 chemicals used to develop and test the approaches. When we look at the accuracy for predicting responses in the local lymph node assay, which is considered the standard reference in vivo regulatory method, we see that the defined approaches are definitively better than the individual methods in predicting the effect. And they also appear to be good in predicting effects in humans. So when these approaches have been compared against human data, it appears they are doing a pretty good work. And some of them also provide useful information that might be useful for potency subcategorization and more defined potency prediction. So bearing this in mind, the Joint Research Center hosted a meeting last year in October, where basically it was a meeting organized by the IATA partners. IATA stands for the International Cooperation on Alternative Test Methods, which is members of this group is EUREL-ECVAM, of course. Then we have ICVAM in the US, the Japanese Center for the Validation of Alternative Methods in Japan, the Korean Center for the Validation of Alternative Methods, and Health Canada. And this group basically decided to have this meeting because it's really committed to try to move forward with the acceptance of predictions generated with defined approaches. So there were more than 20 regulatory authorities represented at this meeting. There was a discussion about the regulatory requirements across the different jurisdictions and sectors, and there were opportunities discussed for the uptake and acceptance of non-animal methods to satisfy regulatory requirements for skin sensitization. What it was generally recognized was that there was the need for the international harmonization and standardization of these approaches to promote their use at regulatory level. And as a first step towards this goal, it was envisaged the development of an evaluation framework for an independent assessment of the defined approaches currently reported in the OECD guidance documents. And the group also recognized that the OECD would be the most suitable forum for the evaluation of these approaches. So, subsequent to that meeting, the IATA released its position that has been published these days. So basically, the position of the IATA partners is based on two pillars. The first pillar is that, I mean, if an alternative approach to skin sensitization can be shown to provide equivalent information to the animal test, it should be given equivalent regulatory recognition and status. And the second pillar is that if a defined approach can be shown to be scientifically valid and fit for purpose, in order to achieve the recognition it deserves, it should be incorporated into an OECD instrument that is covered by mutual acceptance of data to guarantee equal footing with the regulatory animal test. So, on the basis of these premises and these background activities, discussions, and work, the IATA partners submitted to the OECD in November 2016 a project proposal that was discussed at the meeting of the working group of the national coordinators of the test guideline program in April 2017 and was included in the work plan of the OECD test guideline program. So one of the requests that were made at the WNT meeting in April was for the WNT to be strongly involved in the definition and implementation of the project, because it was felt this had some quite important implication on the test guideline program. And the key milestones for the project, as they are currently described in the SPSS, are a systematic evaluation of the uncertainty of the in vivo reference data, and we are talking mainly of the LLNA, but also about human data. And of course, when we talk about the animal reference data, we also talk about the aspects of how well these data are able to predict effect in humans. Because at the moment, there are a lot of studies available, well, in the scientific literature, but not only, showing that there is some level of variability, of course, associated with the LLNA. But we need to have a more comprehensive view of how this variability looks like and how, in order to be able to also define performance threshold for the acceptance of defined approaches. So this is one of the key milestones. Another key milestone, which is the most important one, is the definition of an evaluation framework for defined approaches. And once this evaluation framework is agreed and defined, then we will have the possibility to independently evaluate the defined approaches which are currently described in Guidance Document 256 according to this agreed framework. And if there are any of these defined approaches that can be shown fulfill the evaluation framework, then this can be included in an OECD instrument, such as, for example, a performance-based test guideline on defined approaches that would be covered under mutual acceptance of data. So, as I said before, the WNT felt they want to be strongly involved in the implementation of this project, and for this reason, we will host a meeting, a special meeting of the WNT in Ispra here in Italy in December, where we will be discussing main issues associated to the implementation of this project. And of course, there will be discussion about what constitutes a relevant, suitable, and applicable framework for the evaluation of defined approaches in order to judge whether they are scientifically valid for using them under mutual acceptance of data. There will be discussions to explore how defined approaches, which also include computational methodologies and non-guideline in vitro methods, can be handled in the context of this project. And we'd also probably discuss approaches to better identify and characterize the sources of uncertainty, which are related to both the defined approaches themselves, but also to the in vivo tests, which are used as reference methods, against which the performance of the defined approaches is compared. So I think that's all. Here I don't have conclusions because it's work in progress. It's just we are just facing the initial phases of this project. It was just to provide you with an overview of what's going on, but we are trying to do the best possible to try to keep all the parties involved informed and engaged in the discussions. You know, for example, that we have recently released a survey to have an initial thought starters in preparation for the meeting. So we are really encompassing and try to be as much comprehensive as possible in the information and in trying to keep everybody in the loop for this project. That's all.
Thank you very much, Sylvia, for both of your presentations and also this update on trying to see if a defined approach can become a test guideline. I think it's an important initiative under the whole IATA umbrella to see where these tools can find their way within the OECD frameworks. So prior to opening up for some of the questions that are coming in, we're going to move to Miriam Jacobs from the UK. And while Miriam's sharing her screen, I just want to maybe answer a couple of general questions that came in over the chat function. So we will be sharing the presentations. The idea is to share them on the IATA website, the OECD IATA website. We'll still need to collect these from some of the speakers, but this is the plan, and also on the community site for the IATA Case Studies project. Another general question that came in was that if there is general IATA guidance document planned under the OECD umbrella, and I guess I could just say that right now there's not this sort of higher level general guidance document planned or underway, but the IATA Case Studies group will be meeting in a few weeks, and will also take into input the discussions from this webinar, and also the mapping that Andrea has done, and discuss if there's opportunities in the near term for guidance development. At this time, though, I'd like to turn it over to Miriam Jacobs from the UK, who will present on the non-genotoxic carcinogenicity IATA project. Miriam?
Thanks very much. Can you hear me? Okay.
Hello.
Oh, sorry.
Sorry? Can you hear me?
Yes, we can hear you.
Okay,
Could
thank
you
you.
please share again your
I'm just
PowerPoint?
having difficulty sharing the first slide of the presentation.
It was working.
It keeps coming up on slide 3, and I'm not really sure.
Yeah, you just click on the first slide and then put on full screen.
That's what I've been doing. So I'm going to change the screen. Okay. And do it like this.
And
so,
screen view. Thank you.
Can you? Is that okay?
Yes, if you can just put on slideshow or full screen view. Thank you.
Sorry, it's not working.
On the top menu, you have slideshow.
I did actually send a version to you that you could show, but I'm...
Well, okay, no problem. We will do it. We'll share it. 1 second.
Yeah, thank you. Thank you. I didn't want to jump straight away to slide 3, so thank you very much. So I'm going to briefly present how we are looking at developing an integrated approach to testing and assessment for non-genotoxic carcinogenic chemical substances at the OECD. And this is a large expert group. And the next slide, please. I'm going to talk about why we started to develop this, and the establishment of the expert group, and then go through the work that we've conducted so far and the next steps. So now with the third slide. In 2014, the cell transformation assay failed to achieve test guideline status, and instead it was developed as a guidance document. And the reasons why is that because it was considered insufficient to address non-genotoxic carcinogenic modes of action, we were not clear about exactly how it could be used, and there wasn't a good enough understanding of the mechanisms within the both the SHE and the BHAS42 CTA. But also there were doubts with respect to the predictive capacity of the assay. At the time it was predicting just 57% of the proficiency chemicals, or the reference chemicals, sorry. So we needed to look at a way of developing a range of appropriate assay endpoints for non-genotoxic carcinogenic mechanisms which would complement the CTA more comprehensively. And the guidance document that was developed does point out that they developed several assays that should be considered to prepare appropriate test guidelines in the future. The trouble was is that the CTA was really the only assay we had in the pipeline at the time for looking at non-genotoxic carcinogen mechanisms. And the reality is that certainly within Europe for REACH, the rodent cancer bioassay is rarely, if ever, used. In the last 8 years, it's only been used twice. So although it's used extensively for pesticides, for industrial chemicals in Europe, so in any case, we have not been assessing for carcinogenic mechanisms beyond the genotoxic battery that we have. So this discussion led to the identification by the WMT that we need an IATA approach, to really start looking at this issue properly and to see how these assays could all fit together. So a steering group was formed in the April 2014 meeting to develop a thought starter that could be the basis for an expert group that could be later convened. Next slide, please. And this is the membership of the expert group. Italy, Netherlands, Austria, France, and the UK. Next slide, please. And this is the SPSF that was submitted at the time and accepted onto the OECD Rolling Work Plan in 2015. So the purpose of the expert working group was to first provide a thought starter to underpin the work. It took us 2 years, but we did so. We needed to achieve consensus within the steering group to be able to provide a conceptual framework in which to start basing our discussions. The thought starter looked at the key mechanisms and chemical applicability to domain gaps and started to look at identifying promising assays. And the intention was to facilitate international understanding and collaboration and the regulatory applications of the nations of IATA. And following the further development of the thought starter, the work was able to move to stage 2, which was the initiation of the expert group. There were 2 other aspects of work that we conducted for the basis of the first meeting that we had in March 2016, and these included both the start of a database, a scoping assay effort, very similar to the thyroid scoping assay effort for assays, which was the OECD funded a consultant to help work on with me and with Anna Maria Colacci from Italy. And the other thing that we started to work on is having an overview of regulatory requirements globally for non-genotoxic carcinogens. And this was all preparatory work for the March 2016 first meeting. Next slide, please. So the initial thought starter came with a preliminary definition of non-genotoxic carcinogens. It looked at what non-genotoxic carcinogens are, the regulatory difficulties, and we had started to scope those initially. How we could look at exploring an IATA, and that's essentially it, and it was published in Alltext in 2016. Now we're halfway through stage 2, which is the development of an IATA by the expert group, and we're trying to take a very pragmatic approach, focusing on key commitment steps, and using that to identify the readiness of relevant assays that could enter the test guideline program. But we've hit on a number of problems that I would, as I go through describing the work, I will highlight to you, because it would be really useful to discuss these. The IATA that we're trying to develop, to undertake, is incredibly complex. The sensitization IATA work is a relatively simple endpoint, and a huge amount of work has been undertaken to develop the IATA and then be able to start coming forward with PBTG approaches and defined approaches. And obviously that's a model that we would like to follow, but it's even more complex. The next slide, please. We started by looking at the hallmarks of cancer and the associated modes of action, and we have the 10 hallmarks from Goodson et al. From 2015 that we wanted to build from. And we, next slide, please. I appreciate it might be difficult to see all of the detail, but essentially what we did is we identified the key mechanisms in that first diagram, the hallmark, and then we wanted to look at the relevance of the associated pathways, examples of major genes, and prototype substances. And the more detailed table is available in a couple of publications that are freely available. As part of that, we needed to, next slide please, go into the levels of test information that we needed to consider for the IATA. And these are the levels taken from the OECD IATA Framework Workshop Report. And next slide, please. but we ended up expanding those hallmarks to 13 AOP assay blocks. And these are the ones that we are looking at: receptor binding and activation, cell proliferation, cell transformation, JAK junction intercellular communication, P450 induction, oxidative stress, immunosuppression and immunoevasion, gene signaling and cell signaling pathways, increased resistance to apoptotic cell death, pathogenic and angiogenesis and neoangiogenesis, epigenetic mechanisms and genetic instability, cellular senescence and telomerase, and then finally metastases, migration and survival outside the original tissue. So we have an awful lot of endpoints. We've had a lot of discussions about these, and we did try to condense these down again to be similar to the IARC papers and the Goodson et al. Papers. But the trouble we found with trying to do that, the trouble is that we were maybe limiting ourselves before we mapped out all the assays that we should be really including. So it's something that we will revisit more towards the end of our work to see if we can condense those down. We don't want to exclude anything that might be a key mechanism that we should be including. So in the next slide, this just shows you the initial collection of the assays that we developed. We have over 40 assays in there at the moment. There are a lot more that we have waiting to populate. First of all, we conducted a systematic review, and I had 4 librarians at PHE helping me with that. We were overwhelmed. We had hundreds of thousands of reports, and many of them were not really relevant, were not really assay specific. With all the various fine-tuning that we did, it still, in the end, it wasn't such a good approach to take, and we started instead looking at various databases for assays, and we are going to be publishing a call for assays, hopefully next year, via EURL ECVAM. But this is just to show you, give you a screenshot of the blocks and the assays, and then we have the tabs at the bottom for going into the various blocks. The next slide is just to show you that there are other ways that we can also look at examining these, and with epigenetic mechanisms, for example, there's a huge amount of information available from human epigenome cancer databases with respect to microRNAs that we could use for developing specific assays. And this is just to show you how we can use epigenetics in combination with in vitro assays and further define the epigenetic relevant pathway as part of a non-genotoxic cancer mechanism. Next slide, please. And this is really the conceptual overview of the non-genotoxic IATA in a nutshell, with the various AOP chemical independent factors on the top left-hand corner in blue, in the right-hand, in the left-hand bottom corner, the chemical specific factors, all coming in. We've reorganized the blocks to go from more basic levels to level 2 cellular, level 3 multicellular level, and then level 4 with the whole organism. And where we can, we want to try and look at how far we can go with replacing the whole organism level with a combination of in vivo with in vitro tests where possible. But it's also very likely that we will use omics information, particularly from assays such as ToxTracker that have been that are in validation now on the test guideline work plan. Next slide, please. So now we are looking at how to conduct a weight of evidence and uncertainty analysis and all the relevant in vitro assays, and we've done so for the rodent cancer bioassay as well. We've published a first paper on that, but we're very close to finalising the development of the uncertainty chapter altogether. We have been looking at how to integrate the different approaches into IATA for non-genotoxic carcinogens, but we've also been waiting for the work by Andrea Richards to help us with that. So we've done a first overview, but her work will be incredibly useful for assisting us. And we've also been looking at the lessons learned for IATA case studies. We want to test our IATA as we develop it with case study chemicals, and we want to have a regulators workshop towards the end of next year, hopefully, or possibly 2019. Next slide, please. We've had 2 face-to-face meetings, and we have a third planned for June next year. We've had a great many telecom conferences. The database, we have a task force now to help populate it, and we'll be doing more work on that later this year. We have almost finalised the overview of the regulatory requirements, and my colleague Helen Smith was doing a lot of work on that initially. We have agreed a definition of non-genotoxic carcinogens. We didn't go with the preliminary one. We went with it. We only finally agreed this definition at our meeting this year. I'm going to show you that next. So with the uncertainty work, we have developed a thought starter. We have a detailed study plan for the systematic uncertainty analysis using the OECD guidance documents. We have drafted the uncertainty chapter. It's almost completed. The review of existing OECD work I've already mentioned, and we will have a great deal to gain from the next batches of lessons learned for IATA case studies. We tried to refine the hallmark blocks, but we struggled and agreed not to. We want to look at a more basic level by developing a prioritization IATA to begin with. And we are assessing commonalities and differences between cancer models for non-genotoxic carcinogen aspects to be able to consolidate the key blocks that we need to work forward with assay selection. I'm going to show you that again shortly. And with that, then we can move towards a more comprehensive IATA. And that we're working on developing criteria for a call for assays. So the next slide, please. This is repetition really of what I've already said, so let's go to the next slide, please. The definition that we finally agreed, which took a huge amount of discussion, is this: that the induction of cancer involves the accumulation of genomic alterations which can be induced directly or indirectly. Carcinogens have conventionally been divided into 2 categories according to their presumed mode of action: genotoxic carcinogens and non-genotoxic carcinogens. And then we define genotoxic carcinogens, and we say that non-genotoxic carcinogens have the potential to induce cancer without interacting directly with either DNA or the cellular apparatus involved in the preservation of the integrity of the genome. Next slide, please. We are the work near completion on the uncertainty analysis I've described, and this is worthy of a whole presentation all on its own. It's very extensive. But I haven't mentioned yet how we're using omics information in vitro. So the She cell transformation assay, Italy are leading on a paper to better understand the mechanisms of action leading to the transformed phenotype, and that is in review at the moment. It's using a transcriptomics-based approach and hopefully it should be published in time for a January discussion within the group. And Japan have also been doing a similar analysis for the BHAS 42, which we also hope will be published early next year, so we can have a discussion on this. And then the omics is being developed in vivo, being led by the Netherlands, not only with a tox tracker assay, but also work being conducted by Miriam Luchins on omics in vitro analysis, which is being published. Next slide, please. I mentioned already the relevant guidance and IATA case studies from the OECD. Here's a selection of those that we've looked at, but we really appreciate Andrea Richard's work at the JRC. That will help us a great deal. Next slide, please. What I would really like to flag up is that with respect to the work as we progress, identifying the assays that address key events and key event relationships, and as we populate the spreadsheet and the database, we have a real problem with assays that address later parts of the key events. So with the early parts, with the molecular initiating events and early key events, they're all conducted with the original chemical initiating event. But the active moiety in later key events of the carcinogenesis process is not necessarily the initial parent chemical of interest. And that's something that perhaps easier to understand endpoints such as skin sensitization, it might be easier to overcome. But for more complex endpoints like non-genotoxic carcinogens and for neurotoxic IATA work, how can we address this? This is the sort of thing that we haven't really discovered in any of the guidance documents so far. It's going to be a common problem for many complex endpoints for AOP and IATA concepts. And we would really appreciate a good discussion on how we could start addressing that now. The next slide, please. In these next 3 slides, I'm just showing you the cancer models to show how we've been looking at specific blocks that come up in the natural history of each cancer model. So this is the one for liver. The next is for colon. Next slide, please. And next slide, please. And for lung. And the sort of the key ones that come up, next slide please, are very clearly cell death, cell proliferation, inflammation and hyperplasia. And for the IATA, with the in vitro assays, we have assays as I can illustrate in green that we can populate with. But a key data gap that we need to address to make an in vivo evidence-based step from inflammation and hyperplasia to tumor formation is that circled in red there, that transition. There are some assays on angiogenesis, but how we address the lack of with the molecular initiating event, with the chemical, the connection, is something that we're looking at very closely. There are a number of publications with respect to extrapolating from pharmaceuticals, for example, and I know of a database with respect to pesticides. And so this is an area that we are really looking at developing at the moment. And next slide, please. We also have been looking at which chemicals to conduct IATA case studies with, but we don't have any volunteers to do so so far. But arsenic, nickel, furan, and benzoapyrene have been considered good candidates. And we do want to use these for testing the IATA we develop, and we would like to collaborate with the IATA case study group to look at examples that we could develop together. And next slide, please. I just want to highlight that this is a really detailed project. We're trying to be very pragmatic. We have found we needed to extend our timelines a little. So with much of the work that we hoped to be finishing off this year, in reality we've had to have a lot more thorough discussions and to achieve consensus and to move forward. And there's a great deal of background development work that we have to get ready for our meeting next year. So we've deferred our meeting from next March to June to prepare all the various documents. And we're hoping that perhaps we can have a consultation workshop late in 2018, but it's probably more likely it will be 2019. And it will really be 2019 that we are able to synthesize the guidance documents. Next slide, please. This is just to show you all of the current and past membership. It is a fluid, it has become a bit more of a fluid expert work group member as new people have been nominated by the national coordinators. My thanks go out to all of them. This is a huge group effort, and everybody plays a key and pivotal role. Next slide, please. And these are the contacts, myself and Natalie, for further information and input. Thank you very much.
Thank you very much, Miriam, for your presentation. It's certainly an incredibly complex area to try and develop IATA. So I know the group has been working very diligently and hard on this, and we look forward to further updates as you progress as well within the other group. So I'd like to now field some of the questions that have come in to the presenters. So first of all, I'd just like to thank Miriam, Sylvia, and Andrea for this series of presentations. And maybe I'll go to Sylvia first for a question. So there was one question that, so in addition to the 6 defining principles of defined approaches, there was a comment that we also need a reporting format for the individual results that are provided by the application of a defined approach. So this is sort of analogous to, we have QSAR model reporting formats, and then we have the QSAR prediction reporting formats. And the question is if you have any other, ideas about this type of result reporting idea.
Yes, that's a relevant question. Maybe once the defined approaches will fall under mutual acceptance of data, then we might also think of developing some reporting templates for their predictions, because at the moment, I mean, it was much more important to try to really focus on the reporting of the different approaches themselves, which was the more complex part.
Okay, thanks for that response. I guess it's an idea sort of hinging there for everyone to think about as we move forward. Then I'll stay with you, Sylvia. There was also a couple of questions about the individual information sources. So there was one question was asking what is meant by these, like does it include peer-reviewed literature or de novo research? And also another question on defined information sources, and I'll ask this to you. I mean, the person asking the question was also looking for the group's views, but they were wondering also what level of certainty is needed from each of these defined information sources. Do they need to be test guidelines themselves, or peer-reviewed information, or can they be other predictive information somehow?
Okay, I take the 2 questions. So in relation to the first question, it's my fault. I was not sufficiently clear, possibly in my presentation. When we talk about information resources, we talk about any methods that can be used within a defined approach. They could be either non-testing guideline methods, non-testing methods such as QSARs, read-across approaches, or testing methods that could be either guidance methods, so methods covered by a test guideline, or non-guideline methods, methods which are, for example, in use but are not covered by a test guideline, could be physical chemical properties, so whatever kind of relevant information that can really inform the final prediction or assessment. That's for the first question. For the second question, I don't know. I don't have a reply for that because this is, as I said, under discussion. This is something that will need to be discussed in the context of this new project that is currently on the table of the WNT. So I expect that this is one of the issues that will be heavily discussed in course of implementation of the project.
Okay, great. Thank you. Thank you for that response. And yeah, it's certainly a topic that you know, it's come up in some different forums as well as what are the inputs then as well into the defined approaches. Maybe I'll ask Andrea a couple of questions that came in. So I'll give you two questions here. So one was on the mapping of guidance documents. The submitter of the question was very thankful for the good work on that so far, and was noting that you mainly referred to guidance within Europe, and they were wondering if you have plans to also try and map also guidance from other parts of the world into this mapping. And then there was also a question to ask if, from your point of view, what do you see are the next possible steps in terms of developing different IATA templates or furthering harmonization and standardization?
Yeah, thank you for the question. So regarding the mapping, yeah, and it's a bit European-centric because obviously it's the guidance we also use here. But we have tried to take into account US EPA and WHO international ones. But yeah, we would be quite grateful actually. I mean, if this is being taken up further, for example, in the IATA case study group, if people could point out or add the information, then we could add to the table, etc. And yeah, make it more and more global. And yeah, the next possible steps, I think this would be actually discussion within the IATA case study project, and from getting opinions from all of you today and discussing it further and seeing if there really is a need or what are the needs. Personally, I think it would be useful to have this kind of link or mapping somehow available as a start, and then see if what else is needed formally as type of guidance, and this has to be discussed with everybody.
Okay, great, thank you. I think I'll do one more question here before moving on. So this one goes back to Sylvia, and there was just a request to clarify the ambition of the December meeting that JRC will host, and the person posing the question was wondering, is it specifically to discuss the defined approach for skin sensitization, or will it be a more general discussion on defined approaches as well?
No, the meeting will be devoted to discussions on defined approaches in the area of skin sensitization. We'll be limited to that because, yeah, we need to really discuss several issues before we move forward to other endpoints. We need to solve out important things before. And the aim of the meeting, since the goal is to, one of the key goals within this project is to define this assessment framework for an independent evaluation of defined approaches. The aim of the meeting is to start discussing how this assessment evaluation framework could look like, what are the main features, and how some of the features could be more precisely defined, and trying to have an agreement on this framework in order to enable then to implement the technicalities of the project. I mean, to be able to start really evaluating these defined approaches against this framework.
Okay, thank you for the clarification, and also thank you to that first series of speakers. So we'll continue on into the agenda because it is a packed agenda, and we'll now turn to the AOP development program, and I'm going to pass this to Nathalie Delroux, who's here from the OECD Secretariat, and she'll start off this presentation, and then we'll also move it. Magda Sashana from the OECD will then also continue the presentation on this topic of the AOP development program. So, Nathalie.
Thank you very much, Eva. Magda and myself are working on the coordination of the AOP development program, which was launched at OECD in 2012. The AOPs pull together and structure all information available on how chemicals can lead to adverse effects. And their structures are various blocks, starting with what we call the molecular initiating event, which describes how chemicals interact with, at the molecular level, with a biological target. And then we go to, this molecular initiating event leads to various sequence of key events, which are alteration in the biological processes, starting with interaction or effects at the organelle level, and then at the cellular level, at the tissue level, and leading to an adverse outcome, which can be either at the organ level, at the organism level, or in case of endpoints related to ecotoxicity at the population level. So the way, AOP, the objective of the AOP concept is to guide risk assessors in their work to use all existing information on the effects of chemicals and to target the generation of additional information to the regulatory objective. And so AOPs organize and potentially increase the knowledge of how chemicals induce adverse effects in humans and wildlife. AOPs play a central role in OECD work on predictive toxicology, and they can be used in various areas of the OECD chemical safety program. They can be used at the level of the test guidelines program with the identification of new in vitro test methods that are candidate to become OECD test guidelines. They can be used at the OECD QSO project level with the identification of new profilers for grouping chemicals, and they can also be used in the context of OECD hazard assessment activities in the development of IATA for defined hazard endpoints. And this will be explained to you in the next presentation. So now I will give you some information related to the management of the AOP development program. AOP development and review is under the umbrella of an expert group called the Advisory Group on Molecular Screening and Toxicogenomics. We call it AGMOST, which is itself under the oversight of the Working Group of the National Coordinators of the Test Guidelines Program, the WNT, and the Working Party on Hazard Assessment, WPHA. AOP development is based on a voluntary contribution from countries and stakeholders, and the AOP development work plan is increased regularly with the submission of new projects, and when an AOP which is on the work plan is ready for assessment, then the AOPs are reviewed, and they are subject to a two-step review. The first step is the internal review conducted by members of EGMOST, and which objective is to check the compliance with the AOP User's Handbook. This document, you will hear about it later, is a document providing guidance on how to develop and assess AOPs. The second step of review is called the external review, external because it's conducted by teams of 3 to 5 reviewers outside EGMOST. These experts come from most of the time OECD expert groups who have the scientific expertise in the hazard covered by the AOP. And the objective of these external reviewers is to address the scientific and technical content of the AOP. So once the AOP has undergone this two-step review and has been also approved by EGMOST and endorsed by the WNT and the WPHA, it's then published on the OECD public website in a series called the Series on Adverse Outcome Pathways. So here in this series, you can find AOPs which correspond to the state of the AOP at the time the review was conducted. But of course, AOPs need to be seen as living documents, and they are developed on the AOP knowledge base, where they can at any time be revised, updated as science progresses. So the gaps that can be identified in an AOP can be addressed over time as researchers' community contributes. So AOPs can be seen as a basis for a clear delineation of current gaps in our knowledge, and it's also a transparent recording of the stage of the science at a certain point in time. So AOPs are described as a linear chain of key events, but of course, to describe a biological system, we need to have networks of AOPs. We need to keep in mind in particular that a particular molecular initiating event may lead to several final outcomes, and conversely, several molecular initiating events may lead to the same final outcome. We need to develop networks of AOP. Currently, if you look at the wiki, you can see, well, there are a lot of AOPs at various stages of development, but those that there are around 60 to 70 AOPs that are actually on the OECD AOP work plan. And of course, not all adverse outcomes are yet covered by an AOP. And an absence of a developed AOP doesn't mean that there is an absence of biological flow of responses leading to an adverse effect. So there are gaps in the AOP collection. To date, AOP development is opportunistic and on a voluntary basis. It's a valuable approach to allow learning by doing, to engage academic input, to increase public understanding and stimulate some regulatory use and stimulate awareness regarding AOPs. In the future, we need to have more strategic thinking to address broader regulatory needs and applications of AOPs, and also to identify the gaps and work priorities to guide AOP development work in the longer term. And now I will move on to Magda, who will continue the presentation.
Okay, thank you, Natalie. I hope you hear me well. So as Natalie said, I'm going to present the AOP documents and tools that we have available, and I will highlight where you can find information related to IATA. Next slide, please. I will start with a guidance document on developing and assessing AOPs. That was first developed back in 2013 and has been recently revised and published last year in 2016. In this document, you can find the historical background on the AOP program, and the document also outlines the construction elements of AOPs, as well as the principles of this framework. Within this document, we have a dedicated section on the uses of AOPs, and in this section, there is a subsection that is related to the use of AOPs within the context of IATA. So that's where some more information can be found. Next slide, please. Oops, the previous. So the second document that I'm presenting is the user's handbook that is supplement to the guidance document that I presented. This handbook is currently under revision, and we hope to have it published and get the second edition of this handbook beginning of 2018. In this document, basically, we described more information related to AOP knowledge base and to weight of evidence considerations. Furthermore, this document is more relevant to AOP developers, where they can find really specific information that they can facilitate the building of their AOPs. In this document, there is also another section. There is a section on potential AOP regulatory applications, where basically AOP developers are encouraged to envision how the AOP can be used in the context mainly of IATA. Next slide, please. And now we'll pass to the tools that we have available to search for AOPs, but also to develop AOPs. I will start with the EAOP portal, which is the main entry point for the AOP knowledge base. It's basically a search engine for all AOPs and key events that are currently available in the AOP Wiki and Effectopedia. And in this portal, actually, you can find the status of the AOPs in the OECD work plan, because some AOPs are endorsed and some are in the stage of development. So in a glance, you can get this information on an AOP that you're interested in. Also, by searching through this portal, you'll be able to find the official copy of published AOPs, because as Natalie explained, once the AOPs are endorsed, they are published in the iLibrary series on AOPs. And through this portal, we also have the opportunity, somebody has the opportunity to see the external review reports for individual AOPs. So they can see the concerns raised by the reviewers and how they've been addressed from the developers. Next slide, please. And then we have the AOP Wiki, which is the entry-level module for textual description and evaluation of qualitative AOPs. And this is, again, a place where you can find and search AOPs, key events, and key event relationships. Next slide, please. And this is my final slide. It's one more module, Effectopedia, which explicitly captures quantitative information and models. Basically, Effectopedia provides a collaborative research platform for quantitative AOP development. So we hope that this tool will enable to host models that can be developed as part of defined approaches. And to close, I will give you some flavor about the future, because at the moment, as you've seen, we have 3 modules that they are a bit, they're not that well connected. So in the future, we hope to have one AOP knowledge base where all these elements can be found inside. Something that obviously will facilitate the development and the use of the AOPs. And it will be nice, the IATA developers, if will give us in the future ideas, if they have any special needs that we need to capture in this new tool. And with that, I would like to thank you for your attention.
Thank you very much, Nathalie and Magda, for the overview of the AOP development program. So if you have questions for Nathalie and Magda, just a reminder to send them via chat to me, and we'll do one more presentation, which is me, before we go back to some questions then. So the next overview of work that I'd like to provide for you is on AOPs as a framework for IATA. And this is basically giving you an overview of a guidance document that was published in late 2016, so about one year ago. So this work was conducted under the Hazard Assessment Program. So one area that the Working Party on Hazard Assessment wanted to focus on was the development of new methodologies to assess hazards of chemicals. So to ensure consistency and generate confidence in these new methods, and also to move, hopefully in the future, to more and more increase in the mutual acceptance of not just data, but potentially hazard assessments to avoid duplication of effort. So one thing coming out of these discussions is the case studies project, which Masashi will be talking to you about later. And then the group also is looking at how to apply adverse outcome pathways in a hazard assessment context, and also further IATA in general, and we've mentioned the QSAR Toolbox project. So this is a picture of the guidance document that was published. So basically, it's outlining a concept where AOPs can be used as a framework for developing IATA. So this is found, the document can be found on the OECD website. So the document itself presents a framework for using AOP to develop IATA, and it built upon a workshop that was held on this topic in 2014. And the workshop report and all the detail for the presentations and such for that is also available on the website. So as I mentioned in my first presentation, really IATA are pragmatic science-based approaches for chemical hazard assessment, which integrate different information to answer a specific question. And what we also think is that IATA can help to understand the likelihood of effects at lower levels of biological organization and how they can inform, when combined with other information, how they can inform decision-making in IATA. So if you think about current regulatory toxicity testing, you can see in this sort of red box on this slide here is that most of the data that we get from are from in vivo tests. Some are from in vitro, but they really range in the level of biological organization from in vitro to the organism or population level. But as we're seeing in the furthering of science and in development of new approaches, there are more and more results from testing strategies and test methods targeted at the molecular events and organelle levels and in the in vitro levels. So more on the left-hand side of this diagram of biological organization. And one of the challenges that regulators have is how to connect this information and the outputs of this information with the adverse outcomes that they typically assess in the context of regulatory risk assessment. So IATAs built on AOPs can help to integrate this information because if you think about the in silico or in vitro tests, they can be linked to the molecular initiating events or key events early on in an adverse outcome pathway. So the AOP itself helps to map and organize and integrate all of this different type of information. Here's a sort of a different depiction of it where you see the adverse outcome pathway on top, which you can imagine that the molecular initiating event you have on the left-hand side, and then moving to the key events, these go through then the different levels of biological organization and your adverse outcome pathway. And so at the bottom of this slide, you have the different types of information that can then be, that you might have to link to various parts of your adverse outcome pathway. So the AOP helps to link this information that you might have on the MIEs or early key events, and it links their testing results to adverse outcomes. So also in the initial presentation that I had, I talked a little bit about the sort of general flow for an IATA. And there's really two main areas where an AOP can also help in the construction of of an IATA. So here we see that AOPs can help to evaluate your existing information. They can help you structure it and organize it, and to potentially help you conclude on the existing information. But if you don't have enough information to conclude, the AOPs could also be used to help you generate or identify areas where perhaps you could do some targeted testing or develop a testing strategy to generate more information for decision making. So within the document, I'm not going to go through all of those in the presentation, but it's described how AOPs can be used in the development of different types of IATA elements, such as development of QSARs. It can help to group chemicals into categories. There can be development of testing strategies. There's also, as I mentioned, IATA can help to interpret results of non-standard test methods. And finally, they can also be used to help identify where perhaps new test guidelines or test methods could be developed or further refined. So, for example, here, if you have an adverse outcome pathway and potentially you have for this first key event for which you do not have a particular assay to generate information that would then help inform whether your chemical potentially elicits an adverse outcome, it could be that an assay is developed to specifically probe this key event. So if you think about, for example, the skin sensitization AOP, so this is an older figure, so I'm sure it could be updated, but you have your the skin sensitization AOP sort of linked to the general levels of biological organization, but you can also line up all your different test methods or predictive methods for how you could probe the different molecular initiating or key events or the adverse outcome. So this then would help the assessor organize information that they might have from all of these different assays or predictive methods to help them then do a better weight of evidence assessment by integrating this information. So in the future, the idea is that we'd like to have further examples of IATA that are built on AOPs in various regulatory contexts, so as case studies, for example, and certainly as the number of documented AOPs increase, we can also look to develop IATA frameworks based on these AOPs. And the current focus at OECD is to continue, of course, the development of AOPs and review case studies on the practical applications of IATA. So I will leave it at that for this particular presentation, and now we will move to questions. Connecting to my computer. As my computer just logged out of me, what I suggest we do, because we were going to plan a break for this time, is we take our break now, and then if some questions have come in, then we'll entertain those questions right after the break for Magda and Nathalie, and if there's some for myself, and then we'll continue with the presentation. So I suggest we take a 10-minute break, which will then we will continue at 3:34. So just a quick 10-minute break, and we'll continue in about 10 minutes. Thank you. Okay, welcome back, everyone. We'll get restarted after that quick break. There were no questions that came in for the last couple of presentations, but just to let you know that Nathalie and Magda and myself will continue to be here. If you have questions that come up about the AOP development program, feel free to send those in by chat to me, Eva Leinola. So next, we will move directly into a series of presentations by Anne Gourmelon here at the OECD in charge of the test guidelines program. So the first presentation that Anne will focus on is IATA for endocrine disruption. So I'll pass things over to Anne.
Okay, thank you, Eva, and good afternoon, everyone. So I'll run the next three presentations. Hopefully they are decreasing in length in the number of slides I'll be presenting, so that you don't get too fed up with my presentations. So I'll start with the one on the IATA for endocrine disruption. So in the series of the next presentations, I'd like to say that in these areas it's a bit different maybe from what you've heard previously, although the skin sensitization example is a little bit like this one. There were a number of predating test guidelines by the time an IATA was developed. And that is the case with the endocrine disruptors. So the work at the OECD started more than 20 years ago already. So at that time, we are not talking really about IATA, but we were talking about still integrating testing and assessment. And a task force was established at the time that there were no standardized method for evaluating chemicals for endocrine disruption. Later, that task force has been working over the years on the development and validation of test guidelines in vitro, in vivo, for ecotox, for human health, for evaluating chemicals for endocrine disruptors, and also in parallel has been working on the development of a conceptual framework that was the predecessor maybe of the IATA, a conceptual framework for integrating all information together in increasing levels of biological order. And after that conceptual framework was designed as a skeleton, the test guidelines that were adopted years after year were included in that conceptual framework for screening and testing. Sorry. So there was an initial one developed in 2002, and it was further updated a few years later. And a few years later, in 2009, there was an international workshop to develop guidance for to go even further in the endocrine disruptor testing and assessment. So that guidance document was going to provide a general description of test guidelines, of endpoints included, of mode of action covered, and general and specific guidance for analyzing data coming from standardized test guidelines. So a first version of this guidance document was finalized in 2012. It was the first comprehensive international guide on the identification of endocrine disrupting chemicals, providing step-by-step guidance for analyzing results from standard tests, be they OECD test guidelines or other standard tests, providing evidence for an endocrine mode of action and adverse effects in whole organisms, providing a general description of each test method considered, and also a tabular presentation of all endpoints measured in the test and the modes of action covered. So the main job of that guidance document was to really critically review each standardized test method and analyze what the data tells us about mode of action and adverse effects, and to which endocrine pathway information generated is useful for. So this is the conceptual framework in a nice and colored way. It's much nicer than when you have all the test guidelines crowding the picture. So we won't add the test guidelines here, but here you can see that each level, in fact, is going, as you go down, is going at increasing level of biological complexity, and then several test guidelines fit at each level, but there are no distinction in the conceptual framework of endocrine pathway. So they are all grouped together. And there is also a common understanding that in vivo assays are usually informative for wildlife species and for human health effects. So information you get from mammalian tests can be used in the weight of evidence to inform non-mammalian effects and vice versa. this is a tabular format that I was referring to. It's included in the new version that will come of that guidance document 150 that is being revised and even expanded beyond the 400 pages that it already contains. So this table is in fact one way of presenting the standardized test guidelines and indicating which endocrine pathway is the endpoints measured in the assays are covering. So we are talking mainly about estrogen, androgen, and thyroid pathways. So with this, with endocrine disruption, I wanted to say that we have a natural fit for a framework, an IATA framework to enable countries to develop case studies, in fact. And this conceptual framework lends itself very well because endocrine disruption is one particular suite of effects where there is usually a good level of understanding of the mechanism or mode of action leading to adverse effects. So it follows naturally the AOP concept, and it was initially developed, the AOP concept was initially developed based on the endocrine disruption case. So in the principles of GV 150, in fact, it provides guidance for organizing, structuring the existing data by endocrine pathway. It is based on types of data available. It helps to identify also what are the potential data gaps and what, if needed, if there's a gap, what could be done next in terms of testing to arrive at more conclusive evidence that a chemical is an endocrine disruptor. So all these concepts are very similar to the integrated approach to testing and assessment. Also, with this slide, I wanted to show that by looking at the existing OECD test guidelines that have been validated with endocrine active chemicals, one can see that there is no single assay that covers the entire life cycle and multi-generation, but when they are evaluated together, all these test guidelines, there is a good coverage of all life cycles and all life stages, and there is overlap of the specific windows of susceptibility that one could think of. So similarly, when you examine the same mammalian test guidelines as previously shown, in this example, we are talking about the estrogen pathway. There is no single assay that includes mechanistic data and late key events or adverse outcomes. However, when they are integrated following the guidance provided in the GV 150 and evaluated in a weight of evidence approach, the results of multiple assays may indicate potential for endocrine active chemicals. So you can apply that same approach and derive some case studies using the thyroid pathway, for example. And here, that's what we have done, and we have put side by side the mammalian test guidelines with wildlife species. Here, the amphibian metamorphosis assay and the larval and developmental growth assay in amphibian as well, as they are in these two test guidelines on amphibian are informative of the thyroid pathway. this is on the light shaded cells. These are indicative of optional endpoints that are included in the test guidelines that are also informative of the TARID pathway. And we can see here, obviously, something that has been identified as a gap, not a data gap, but a gap for standardized assay on in vitro method for the TARID pathway. There is none at the moment, and the URL EGVAM is has just started a big effort to fill that gap for standardized test guidelines for in vitro TARID assays. So one of the earliest example, as I was saying, to illustrate the AOP framework, was using data from endocrine assays to illustrate links between aromatase inhibition in fish. And since then, the use of AOPs has exploded in the last 5 years. AOPs, as Natalie and Magda were presenting earlier, are now used to guide IATAs and will be even more in the future, and to help build predictive models. And that's what we hope will be the case as well in the future in the area of endocrine disruption, is to be able to use the in vitro assays to predict the early key events in vivo, and build some predictive models, some in silico predictive models. And as an illustrative case, that's what the US EPA has started to do with the development of a performance-based validation of the ER model. So they are using 18 ER in vitro high throughput assays included in ToxCast. They are integrated all these in vitro assays to develop a model, and this model predicts the in vivo uterotrophic bioassay. And now the US EPA accepts model results in lieu of the uterotrophic data. And from what I understand, they are going to present this IATA or defined approach as a case study next year to the case study project. So that was, so what I wanted to show is that with the endocrine disruptor testing and assessment work at the OECD, we are building the large framework for countries then to be able to develop their case studies in a structured way for developing predictive models, but also for facilitating the documentation on the and the justifications for the assessment of chemicals by assembling together data on modes of action together with data on adverse effects. So, thank you.
Thank you, Anne. I'll let you catch your breath there before the next presentation. But yeah, certainly you've highlighted how our definitions and terminology continue to evolve. So we talk about IATA now, but really we have been doing IATA along the way and just calling it different things. And so that's how so many different project areas certainly fall into this same framework. I just wanted to remind people that they can send me any questions through the chat function. But then also one of the things that we're trying to get out of this webinar is also where people might see some synergies or areas for collaboration between different projects. So feel free to send along those ideas if you have any things that's triggered from different presentations as well. And I can kind of read those out as well at the end that come in. So I will switch things back over again to Anne, and she will now talk about serious eye damage and eye irritation and the IATA for those.
Thank you, Eva. So I'll follow on with a presentation introducing the work that has been going on recently at the OECD to develop a guidance document on an integrated approach to testing and assessment for eye irritation potential. So although the guidance document that I'm going to introduce in a couple of slides has been published this year, it's such an active area of constant development, I would say, that it's probably going to be soon reopened to be further refined. The willingness, as I understand, of the member countries and all the experts involved in this work is to, within the coming years, to go beyond just an IATA framework and workflow to something a little bit more, even more defined and structured and fixed in terms of prediction for the various categories of the GHS. So I'd like to start. This project, in fact, was to develop an IATA for eye irritation, was proposed at a stage where there were already several alternative test methods, in vitro, ex vivo, well, we call them in vitro methods, that were already adopted. Each of them having their specific purposes, their own applicability domain, their own limitations, sometimes providing a lot or limited information. So the initial proposal came from the United States, who thought that, well, having all these alternative methods, and in the US they are not implementing fully the GHS, so they wanted to still be able to follow what was going on in the test guidelines in these in vitro test methods, and have structured guidance on how to use these alternative methods. So the alternative methods we are talking about here are completely tailored to the UN GHS classification categories. So with this slide here, I'm explaining again why it was important to develop that integrated approach to testing and assessment, and because there were multiple alternatives and there was no standardized approach for integrating these various tests and other sources of information all together. There was also no strategy on how to generate additional data if that is needed. The disadvantage of not having any strategy is that regulators may adopt their own methods and own strategy, leading to the loss of financial savings for countries and industry. I'll go to that slide first. In fact, it's so I explained already the first bullet point. The project was originally initiated by the US, but those who had most experience and most knowledge were the European Commission, who had participated in the validation of and peer review of several of these alternative methods. And the OECD Secretariat had a bit of funding for consultants to help with the development of a guidance document. And of course, we have an expert group on eye irritation testing, composed by experts from several countries, and they reviewed this document during the drafting on several occasions. So the document is organized according to several modules. It's been published in July last year. It's guidance document 263 in the series on testing and assessment. So these modules are about existing human data, in vivo animal data, then in vitro data coming from standard OECD test guidelines, then other existing animal data, other data from non-OECD alternative methods, existing data on skin corrosion, which are also used to inform hazard on eye, physical chemical properties, non-test data, and then phases and elements of the weight of evidence. And also, there is a diagram, and I'll go through a bit more detail on that flow diagram, that testing strategy that is there in blue, but very small. I'll put it a bit bigger. But the guidance document, so beyond the modules in fact are addressed using the same criteria, so you have the same structure through all of the modules. That was also a way to make sure that all test guidelines were described or sources of information were described in the same way. So again, with that need in mind that we need to be very standardized in the way we display information. So the same criteria are used for description, limitations, applicability domain, etc. So beyond that, the IATA is also about your problem formulation, introducing a rational use of standardized non-animal assays in the practice for deriving a hazard classification. That's the problem formulation for this guidance document. Then it's about gathering of existing information, weighing the evidence. If I have everything I need, can I make a regulatory conclusion? If not, how to generate additional information, and that's where that blue balloon on the left side is coming into play, which provides a strategy for additional testing when needed. And then you ask your question again, can I derive a conclusion? Yes, no. If not, the rabbit test is presented as the last resort. Yes, so coming to that flow diagram, first you assess, you collect the existing data, you assign weight to data sources, and you evaluate whether classification can be derived, yes or no. And if not, can you conclude? If not, the core of that testing strategy is about where to, if additional data needs to be generated, how do I make a choice of the most appropriate method depending on the likelihood of serious eye damage, which is category 1. So do I have a risk of a severe eye damage, or am I in the situation where there's little risk, and apparently the existing data indicates that there will be no need for classification, and how do I use the data provided in the different modules as sources of knowledge of the applicability and limitations of the in vitro and in vivo methods. And then when I have done any further testing that was recommended, can I conclude? And if not, because there are cases where given the limitations of the existing in vitro assays, there are cases still where the animal test might need to be conducted. And that's in particular going back here, that's particularly the case for those chemicals for eye irritation where the middle categories of eye irritants are badly predicted. There's a lack of specificity, in fact, in the prediction. Usually the strong irritants are well predicted. The no category are also well predicted. There's little risk of misclassification if you want to simplify a bit. But for everything that is non-category 1 or no need for classification, everything in the middle, the irritants are not specific, and further testing is most of the time needed for those. And currently, the alternative assays are bad about making predictions for the category 2, if you will. So that's why the animal, it's impossible at the moment to delete the animal test. Here I've listed all of the alternative methods that we are talking about here. It's the test guideline 437, which uses bovine eye. Then the test guideline 438, both of them have been adopted originally in 4 years ago. The 438 is the isolated chicken eye test method. Then there is a guidance document also providing guidance on how to do histopathology, which until now was an optional endpoint, but soon it's going to be an additional endpoint for further identification of the category 1, the strong severe irritants for the eye. Then there is a test guideline 460 on fluorescein leakage test method. That's a complete in vitro, not an organotypic test method. The test guideline 491, short-term exposure method, and then the 492, which uses reconstructed human cornea epithelium. Yes. So I just indicated in the medium column there what is the function of each of these test guidelines, if they are good for category 1 identification or for the negative, the no-cat chemicals. So you see that some of them are good for both, some are good for just one or the other. And I put some of the figures for the predictive capacity of the approaches. Usually when the test guideline is used for the category 1 chemicals, we say that that's the bottom-up approach. So the top-down approach, the top being the severe and strong irritants. And when test guidelines are identifying the no-cat, the negative chemicals, we use them usually for the bottom-up approach. So when you hear now about the top-down and the bottom-up approaches, you know what it means. So there are still a lot of remaining questions, especially for in the area of eye irritation, and that's why we continue to work and refine and reopen soon the guidance document 263. There are some remaining questions, also reflecting on what has been done. A valid question is whether it was a good thing to base the OECD documents, the in vitro test guidelines and guidance document on the GHS classification criteria, because it's one area where test guidelines are almost exclusively used for GHS classifications, but that's generally not the purpose of all OECD test guidelines. They are not typically tailored for GHS classification. So that's a question we can ask ourselves. Also, for countries that are not currently applying the GHS, are they finding the fact that we base everything on the GHS criteria as an encouragement to move to a harmonized classification system? Thinking of countries like the EPA, for instance, there are limited areas or sectors where the GHS is applied. So have we introduced a difficulty, or is it an encouragement to move towards the GHS with having everything based on the GHS classification criteria? And then a question we have also is how broadly are the IATA guidance document and alternative essays used in lieu of the rabbit eye test in OECD member countries. So what we call the last resort, the rabbit eye test, is it really the last resort, and how last is it? And then this is my last slide, what we envisage as the possible next steps and developments in this area of eye irritation. We are wondering whether there are other test methods and endpoints that could help better predict the moderate irritant, everything that falls in between that is difficult to predict. And for the moment, the experts in the OECD expert group have not identified any other method that could do a good job at predicting the category 2. So in the alternative, there's a lot of work and time and resources from experts put into developing testing strategies combined with prediction models, so we could call that defined approaches, combining some of the alternative assays together to predict the moderate irritant, the category 2. Yeah. And the last question is a bit redundant, I think, to the first 2 bullets. So that concludes my presentation for eye irritation. Thanks.
Thank you, Anne, also for that presentation on eye irritation and really a very developed IATA that has been created for that endpoint. You heard Anne had also some questions at the end about things that the team there is working on this is thinking about, things like linking to the GHS and the value of that, linking the IATA framework to the GHS. And then also how they can improve prediction for the moderate irritants. So also if you have any reflections on the questions that she posed, feel free to type those in as well. So I'd also like to congratulate everyone. I think 95% of people have stayed online already for 3 hours. So we know it's a marathon WebEx, and it's hard to stay online for that long. We have 4 more presentations, so I continue to hang in there. I know the presenters at the end will really appreciate having everyone present as well. So I'll move again to Anne for her 3rd presentation, where she'll focus on skin corrosion and inhibition and the IATA for that. Thanks, Anne.
Yeah. Thank you, Eva. So this is my last and shortest presentation. There are only 6 slides. So I'm this presentation is quite similar, I would say, to the work that has been done, that is ongoing on eye irritation and severe eye damage. Maybe with the advantage that here things have been a little simpler, and work on the development of a guidance document was completed in 2014 with the guidance document 203 in the series on testing and assessment. So very similar to the area of eye irritation and corrosion. For skin irritation and corrosion, there were predating test guidelines. Predating test guidelines addressing specifically either skin irritation in vitro or skin corrosion in vitro. These test guidelines had been developed as alternative methods in the period 2004-2010. The first one was the transcutaneous electric resistance. It's not completely in vitro in the sense that it's using rat skin. It's a reduction, refinement test method. It's used for skin corrosion exclusively. Then the test guideline 435, also known as the Corrositex test method, that's completely in vitro. It was originally adopted in 2006, so it's fully non-animal. It's also completely used just for skin corrosion potential. And then two in vitro test guidelines which are very similar in the sense that they are both using reconstructed human epidermis. The one on skin corrosion, that's the 431, was originally adopted in 2004. And the one for skin irritation was adopted in 2010, and that's the test guideline 439. But in each of these two test guidelines, I would say almost the same, exactly the same tissue models are included. So when did we start talking about an integrated approach to testing and assessment for skin irritation corrosion? In 2010, so when the test guidelines, in vitro test guidelines were adopted already, there was an expert meeting in Berlin where they discussed the need to revise the in vivo assay, the test guideline 404, and get rid of the sequential testing strategy, which was a supplement to the test guideline 404, that was leading, in any case, to a confirmatory in vivo testing. So after the in vitro test guidelines and the possibility to conclude on the skin irritation or corrosion potential, it was really needed to get rid of that sequential testing strategy. But at the same time, getting rid of any strategy, there was a need to consolidate the alternative test guidelines and promote the view that altogether, used altogether, they can satisfy the regulatory needs for core classification according to the GHS. So there was a need to replace the supplement to the test guideline 404 by an integrated approach that guides users on the weight of evidence of existing data and what tests to perform first to avoid also multiple and unnecessary testing. Because you don't have to do all of these in vitro assays to be able to conclude. There's a logic behind, and this logic needed to be explained and communicated. So that's why that's how IATA was developed, and Germany was the lead country on that. If I remember correctly, the same consultant who used to work on that testing strategy for skin irritation was also developing the one on eye irritation, and maybe she's on the webinar today. It's Chantra Eskes. So together with Chantra, Germany and the OECD expert group on skin irritation corrosion, it was possible to develop and refine that testing strategy. So the first part, very similar to what I presented for eye irritation. The first part here is initial assessment of existing information. That's always the first step before conducting any test. And in the guidance document 203, there is extensive guidance on how to evaluate the existing information, and that is used. That can be used already to conclude on corrosive potential, irritation potential, or no category, if possible. And if it's not possible, then you go to part 3 of that flow diagram, which is the testing strategy. So that testing strategy was originally, I think, where we started to use the terms bottom-up and top-down approaches. So in fact, yes, these when we talk about bottom-up and top-down, we are talking about these 2 test guidelines. One is used in the top-down, that's the test guideline 431 on skin corrosion. So that's to identify the category 1, the strong, the corrosive chemicals, while the other one is used in a bottom-up, is to identify first the irritants, so the less severe, if you will. Then also an analysis post-publication of that guidance document. Well, there are clear advantages. When we developed that guidance document, it was relatively simple because the modes of action are relatively simple, and they have been mimicked in vitro test methods. And the prediction models are quite simple, I would say, also, and transparent. They are not complicated algorithms. So they are relatively easy to understand also for the users and easy to accept. The validation performed for the in vitro methods and the prediction models were adjusted to really fit the in vivo GHS classification category. So again, we are in the situation where the test guidelines are really used for the GHS classification. And here the GHS classifications, the categories are very, they are very clear-cut, so that's easy when developing, easier when developing alternative methods. And the alternative methods were already available before the development of an IATA, so that IATA guidance document could be, was relatively simple. Nowadays, we could almost consider that that guidance document, in fact, is almost a defined approach because it's sufficiently standard. The data interpretation is fixed, and it's also broadly applicable. Yeah, also we could ask ourselves a few questions that I listed here. We have no knowledge, no feedback on the level of use and application in all OECD member countries of these guidance documents and these guidance document 203 and the test guidelines. We don't know how it's used across chemical regulations. especially in countries not applying the GHS. Again, like for the higher irritation, we can ask ourselves whether it was a good approach to benchmark everything against the in vivo GHS categories, because in the future for other endpoints it might be more difficult to apply, to replicate that approach if we wanted. And in future we can also ask ourselves what should come first. The test methods with some validation, some level of validation, or the adverse outcome pathway, so the conceptual pathway with the and understanding well the biology behind. So, and that concludes my third presentation. Thank you very much.
Thank you, Anne, for the third presentation and the whole series of the three presentations. So Anne also had some questions at the end of that presentation that you can reflect upon. Again, the value of linking to the GHS in building this scheme. And I think also an interesting question is this already a defined approach that we have developed here in the context of this guidance document? So Anne was so clear that no one has any questions. So I think we'll move directly to the next presentation, which will be from Magda Sashana. And she will focus on developmental neurotoxicity. And here, in this presentation, you'll also get a break from PowerPoint, as Magda will be using, I can't remember what it's called now, Prezi, thank you, Prezi. So Magda, I turn it over to you.
Thank you, Eva. So hello again. This time I will talk about an IATA-related project that we have on developmental neurotoxicity. I will give you some background first. Well, the last 2 decades, there was an increasing number of scientific papers expressing the need for more chemical testing in the area of developmental neurotoxicity, and also was expressing the limitations of the current available in vivo method. But it was only in 2014 when was this need was better articulated from a regulatory authority through a recommendation that came from the Plant Protection Product and the Residues panel of EFSA. So based on this recommendation, as you can see, the need was expressed for the development of a DNT in vitro testing battery to be used as first-tiered approach. Since then, EFSA conducted an external literature review on in vitro and alternative DNT testing methods that was published in 2015. Last year, OECD jointly organized with EFSA a workshop on DNT and the use of non-animal test methods for regulatory purposes, and there was also a background document explaining the readiness of the different in vitro and alternative DNT testing methods. And in April of this year, the WNT received a DNT project proposal that accepted and included in its work plan. As you can see, this project is led by Andrea Teron and EFSA, Susan Hugert-Beneku from Danish EPA, and Kevin Crofton from US EPA. The overall goal of this project is to develop an OECD guidance document on DNT in order to accelerate not only the development but also the use of in vitro and other alternative assays, so we can have a cost and time efficient testing of chemicals for their potential to disrupt the development of the nervous system. In terms of timelines, since April, when we had the inclusion of the project proposal in the WNT work plan, we have the formation of the DNT expert group, and the Secretariat, together with the leads of the project, agreed on the outline of the guidance document. Early next year, we plan to have the leads kickoff meeting, as well as our first TC with the expert group on DNT. And as you can see, and I will explain later better, we plan to generate some data. So there is some experimental work that is involved that we hope that will complete mid-2019. And all this data will fit in the development of the guidance document that we expect to be released end of 2019. Going back to the outline of the guidance document, just to highlight some sections that are relevant to IATA, because that's our subject today. And you can see there is a section on composition of IATA for DNT. There's a section of integration of in vitro tests for different regulatory purposes, as well as a section on in vitro data grouping according to neurodevelopmental processes. And finally, another section on phases and elements of weight of evidence approaches. As you understand, mainly for the second and third section, there is a need for data, and that's why there've been two calls to funding opportunities to generate this data that came from EFSA and the Danish EPA, and the calls are open, or we'll find out who's going to do the work by next month. So we don't need, of course, only experimental data. We also need case studies, and we need case studies that can cover different application domains, like screening and priority setting, as well as hazard characterization. And we are lucky here that we already identified a volunteer. And of course, we're going to use these case studies to illustrate the practical applicability of the guidance document. We also use the case studies to facilitate data interpretation and harmonize the reporting of DNT IATA. Just to give you now an example of IATA, how we envision this IATA in terms of developmental neurotoxicity. These figures obviously came from a parallel activity that lots of experts that are in the OECD DNT expert group contribute, and they're part of a publication that is under preparation and will come out very soon. So you can see here the steps that were described even before from Anne or Eva or Sylvia. So you can see that we go first and we gather the existing information, and so if there's adequate information, then a regulatory decision was making. Otherwise, we generate additional information. But in this case, we defined the problem formulation. So we are talking about IATA that is addressing the need of screening and priority setting. So when there is a need in this case for additional information, it is advisable to retrieve this from in vitro assays that measure specific or key neurodevelopmental processes or key events that are coming from relevant DNT AOPs. And just moving now to the right panel, so this group went further to discuss the regulatory decision. So when the compound that we're looking for gives a DNT effect, and that comes from in vitro method, then there is a need from in vitro in vivo extrapolation. And in case that we have a health-based reference value established, and which is quite common for the pesticides, then we can draw a decision. Otherwise, we can look into the margins of exposure. And here is another example how we envision the IATA if it's to be applied for hazard identification and characterization. So in this IATA, you can see that there is another important question that has to be answered in the beginning, and this is related to if the compound of interest give DNT effects by an endocrine mode of action. In this case, of course, we don't use the DNT related IATA, but we go to the regulatory decision directly. So if we exclude this endocrine mechanism of action, and we gather the existing information, and also we weight the evidence, and we find that they're not adequate or enough, then we can generate an additional information that follows this proposed tier testing strategy. So as the first tier, we're looking for in vitro assays, where in the second tier we can use neurobehavioral information that comes from zebrafish, and as a third tier we have the targeted in vivo testing. So we use all this information from the in vitro assays and zebrafish to have more targeted in vivo testing if it's needed. And after assessing our new evidence, we can draw regulatory decision. It can be related to the classification and or labeling, or it can help to establish or confirm the health-based reference values. So as I've said, this is something that will come from a paper in a paper very soon. And that's my last slide. As a summary, as you can see, we have a long way ahead. So as the first phase, we'll try to reach consensus on the test to be used in a DNT testing battery, or establish criteria. That's something else that part of the expert group has worked on and will come out in this publication that I've mentioned. Then we have to identify the gaps in biological and chemical space that are important for regulatory application of the battery, or then to draw a roadmap for the fit for purpose validation of the individual test, but also of the whole battery. Finally, there is need to develop and test a chemical library for challenging not only the battery, but also the individual test. And after doing all that, we can pass to phase 2, or it can be parallel activities that will take place, so we can have the definition of the application domain of the individual test and the whole testing battery, or the development of data interpretation and drafting of guidance, and at the same time we'll have the development of the case studies of data use in an IATA context. And with that, I would like to thank you for your attention.
Thank you, Magda, for your presentation and to give us an early overview of what the DNT project will encompass and what we can expect from that. Certainly also another challenging endpoint to look at developing IATA and new methods for. And so next we have Masashi Jorge here from the OECD. For those of you who have been involved in OECD work and haven't met him before, it's because he just started about a month and a half ago. And one of his first tasks was he inherited the organization of this webinar. So he will also be presenting the work on the IATA case studies project for you. So I will turn things over to Masashi.
Thank you, Eva. As Eva mentioned, I'm joined the OECD in September, so this time, please, easy on me. And now I'm working on the IATA case study project. So today I'd like to introduce the IATA case study project activities. Here is the background. So member countries have been making effort to expand the use of alternative method. At the same time, the OECD has been developing guidance document and tool for the use of alternative methods such as QSA, chemical categories, and IATA. So there is an ongoing need for the investigation of the practical applicability of these methods and or tool and for real case studies or assessment. And therefore, in 2014, the TFHA, now WPHA, proposed the IATA case study project as one of the high priority projects to increase experience with the use of IATA by developing case studies. The proposed project was endorsed at the joint meeting in November 2014. So the objective of this project is to increase experience with the use of IATA by developing case studies and to create common understanding of using novel methodologies and the generation of consideration and or guidance stemming from these case studies. The project team consists of 10 member countries, EU, BIAC, and ICAPO, and deliverable will be in the form of guidance document on methodology with the associated case studies. So this is a summary table of 9 case studies reviewed in the first and second review cycles. The assessment approach of case studies classified into 3 types. First one is data gap filling by lead across in the 7 case studies, and the other is grouping for cumulative risk assessment and safety assessment workflow. The target endpoints of case studies were mainly repeated those toxicities in 6 case studies, and other is neurotoxicities, mutagenicities, and bioaccumulation. The 5 of 9 case studies illustrated the lead across for repeated those toxicities. And also every case studies addressed some challenging IATA topics, such like use of MOA or AOP, and capturing and communicating uncertainty, use of new approach methodology, and last one is low or no toxicity predictions. So from this slide, I explain the overview of the first review cycle. So there were 4 case studies in the first review cycle. These are focused on the lead across, then also developed based on the actual case for regulatory use of IATA in the author's countries. These case studies were published in the September 2016 with the consultation document, and these documents are available on OECD IATA webpage. And also the consideration document describes the learning and lessons from case studies, and also included the strong aspect and uncertainty of each case studies, and also the area identified for further developing guidance. So this is the first meeting held in the 2015 November. The 13 delegation attended, and we discussed the three main topics: the revised case studies, identification of area for further developing guidance, and the proposal for moving the project forward. So there were 6 areas identified for further guidance development. The 2 areas, definition of analogs or category boundaries, and uncertainty analysis and reporting, were identified as the highest priority areas because they are common important areas in the first review cycles, which they impact on the conclusion of the result, and also in addition they were needed to accept for use of IATA for regulatory use, regulatory purpose. So this is the outcome discussion in the first meeting. Comparison between different case studies will be helpful to identify common challenges, and also the experience from case studies demonstrates the value of working collaboratively through the case studies as a promising way for expanding the use of alternative methods. So the learning and the lesson from case studies could be used for revising the grouping guidance in the future. However, the work to develop the guidance should not be started at this stage because more case studies are needed, and also they fit into the grouping guidance, but it should not be reopened at this point. Document capturing the learning and the lessons, which is a consideration document, should be published every review cycle, and the consideration document should be used as practical guidance before developing a formal guidance. From this slide, I will explain the overview of the second review cycle in 2016. So there are 5 case studies in the second review cycles. These were focused on the assessment approach used as lead across, and safety workflow assessment, and also cumulative risk assessment. And these were just illustrative example. So it means so these case studies should not be interrupted as official regulatory decisions made by in the authors' countries. And also these case documents are published in this September with the consideration document. This document is also available on the IATA case study webpage. And the lesson and learnings in the second consideration document updated by adding the 5 by new review experience of 5 case studies. Also, the consideration document especially focus on the lead across for repeated dose toxicity based on the 5 case studies in the first and second review cycles. The second meeting held in November 2016. 12 delegation attended, and we discussed the activity for developing guidance additionally, as well as the same 3 main topics. So first of all, all the case studies were agreed to be discussed, and there were 4 there are 4 areas identified for further developing guidance. Uncertainty analysis and reporting is also identified in the first review cycle, but in the second review cycle, the importance also demonstrated. So that's why I added this area in this slide. So in terms of discussion on activities for developing guidance, we had enough experience to begin to develop an annex to the guidance on grouping chemicals regarding consideration for capturing and communicating uncertainty in lead across. Before embarking on guidance document, it will be helpful to map out where there are existing guidance available on the issues raised. Also, it would be helpful to hold an information exchange workshop on IATA activities to understand all the pieces and developing in parallel ongoing activity on IATA. So that's why this is the reason why today's seminar is held. So in terms of the third review cycle, there are 4 case studies, and the case studies classified 3 types: lead across for the first one is workflow assessment, and second one is prioritization, and the third one is lead across. Fourth one is lead across. The target endpoint was varied, such like estrogenicity, ecological effect, genotoxicity of nanomaterials, and last one is repeated toxicity. So this is the schedule of the third review cycles. We had 2 teleconferences to present all of the case studies, and all of the first case studies all of the case studies were reviewed, and the authors considered to comment from reviewer and formulate any responses. At the same time, all project members identified themes from question responses. Now, 3 of 4 case studies are circulated as a revised version with the response form. And the third meeting will be held on November 27th and 28th at the OECD Bologna in Paris. So now, in terms of the 4th review cycle, we received the 2 nominations, but we welcome additional nominations of your case studies. The deadline of submission is the end of March 2018. Please contact Eva and me for further information if you are interested in the project. And this is my last slide. Further information such like the published case studies and consideration document are available on website OECD IATA webpage. also, you can get the information from EHS newsletters. And thank you for attention.
Thank you, Masashi, for the overview of the case, IATA Case Studies project, which also brought us here today to have this discussion on information sharing. So as Masashi mentioned, the group will be meeting at the end of November. So we'll be also then discussing what we've heard at this WebEx to help inform where perhaps some guidance could be developed, and Andrea will be also presenting further on her mapping exercise and will have existing guidance, and we'll have a discussion about that as well in the context of trying to identify if there's value in developing further guidance on different areas. So I'd like to move now to the final presentation of the day, which will be Juan Diego Cintes from JRC. So we thank Juan for hanging in there to be our last formal presentation. And feel free also to send in your questions as Juan is presenting. But he'll be focusing on the work that's been done on grouping of nanomaterials. So I'll turn it over to Juan.
Actually, I have changed a little bit the title of the presentation because actually I will concentrate on the meeting on grouping and read across for hazard assessment of manufactured nanomaterials that was organized by the OECD last year. And it's a privilege, I have to say, that to be in this, being the last presenter in this webinar and having so much time to present. But I promise I will not try. I will try to keep the presentation short and within the time allocated. As an outline of this presentation, first of all, I would like to present a little bit of context regarding the working party of manufacturing nanomaterial, and some background about some specific consideration regarding the grouping and read across for nanomaterials. And as I mentioned at the beginning, I will concentrate in the OECD expert meeting on grouping and read across for hazard assessment of manufactured nanomaterials. As you may know, some of you, but I think it's worth to remind you, in 2006, the Working Party on Manufactured Nanomaterial was established in the OECD in order to promote the international cooperation for human health and environmental safety-related aspects on, for manufactured nanomaterial, and to be able, by collaboration, to attain a rigorous evaluation of manufactured nanomaterials. You may know that the Working Party is divided in several steering groups. I will not mention all of them. There has been several reorganizations, but there is one in particular that is devoted to testing and assessment, that has as a main mandate to review the OECD test guidelines and guidance document, and to, when it's necessary, to update them or revise them, and if necessary, develop new ones that are able to address the possible hazard posed by manufactured nanomaterials. And of course, it is always a high priority for the group to find and explore alternative methods that include in vitro testing and approaches that include grouping and read across. And for doing this, the steering group on testing and assessment has been organizing a series of expert meetings, and you have a list in these slides. And but I would, as I mentioned, I would like to address today the last one on grouping and read across that was in April 2016. Regarding some particularities of the nanomaterial regarding grouping and read across, The main one would be that is the great variety of nanoforms that a single substance that is considered a nanomaterials could present. The nanomaterials can be variable regarding in size distribution. They may have the same composition, but they still have different shapes, that they can have different coatings or functionalizations, and of course crystallographic structures. And it would be an overwhelming task to test all of these nanomaterials or nanoforms, each of them. And in addition, it would require a lot of resources in terms both of budget and time, and as well on animal testing. So there is a urgent need to know, to understand how the data of one nanoform can be used to fill data gaps that may exist for the hazard assessment of other nanoforms of the same substance. So the expert group meeting on grouping and read across from nanomaterial that took place in April 2016 had the intention to have a common understanding of the aspects of criteria that had to be considered when applying grouping and read across for hazard assessment of manufactured nanomaterials, and if possible, to provide initial input for the update of the guidance, the OECD guidance document on grouping of chemicals that has been already mentioned at the beginning of this webinar, and in particularly the section 6.9 that refers to nanomaterials, and currently is only no more than one paragraph, that is not even one page of guidance there. And the idea was to try to see whether there was possible to develop a roadmap or timetable to come forward with some guidance in this sense. So the agenda of this meeting consisted of first day on where we try to share experience between academia, industry, and authorities when trying to apply these principles of grouping and read across to nanomaterials, and as well discussing them and try to extract some lesson which would be best practices, and at the end to provide some recommendations for applying grouping and read across to nanomaterials. The expert meeting was divided in the second days in breakout groups discussions. The first two of them were divided, were devoted to discuss on the one side the criteria for grouping and read across for human health endpoints, and the other one on the environmental hazard assessment. And there were another breakout groups, two other breakout groups, that one was devoted to particular adaptations that would be needed to apply grouping to nanomaterials, and another breakout group that was more concentrated in the quality aspect of the data that would be needed for this. So this is a slide that has taken from my colleague Eric Blecker, that is mentioned at the beginning from our IBM, but is essentially a common work that was emerging already in the workshop, that the idea of concept that is emerging for applying grouping and read across to nanomaterials is based in these four concepts of what they are, instead, and what in the terms both on the physical identity and the chemical identity that is defined by a number of could be defined by a number of properties like the ones in blue that are in this slide, and then where they go, what they do. Where they go would be more or less the kinetics, the absorption and distribution, the factors that determine the absorption, distribution, and exposure of the nanomaterials, 2 nanomaterials of humans and environment, and what they do, what would be their reactivity, and what there would be their biological reactivity. So the concept in reality is really essentially very similar to what one would apply for general chemicals, starting for the identification, but in this case it's much more complicated because we are talking about nanoforms that, as I mentioned in the beginning, can be identified by many other characteristics in addition to the chemical composition, and try to develop sequentially an initial grouping and develop a hypothesis that has been to be substantiated, and then by an iterative project fill the data gap that was the intention when we started the exercise of grouping with the material we had in mind. So after, and I go already now to the conclusions of the workshop, and in general, it was concluded that the general scheme that is used for conventional is in principle applicable and possible to apply it to the nanomaterials. However, there are specific guidance that is needed. Indeed, as I mentioned, that is the need to develop guidance to assess sameness and similarity between manufactured nanomaterials, indeed of what we call nanoforms of the same substance. And what would be the relevant information that has to be considered for developing a robust justification for reading across between manufactured nanomaterials. And there is already material to initiate the development of some specific guidance, more specific guidance for the OECD document. However, this guidance would need to be updated very soon and very quickly. So because the information and knowledge is developing relatively quickly, and so that would require an effort to keep this guidance updated frequently. And of course, this has to be in the guidance that would be eventually developed and put into the guidance document would need to be tested and sustained by case studies. The parameters criteria that were proposed during the discussions and that have been illustrated in the previous line were considered the valid parameters for initiating this grouping and read across, but of course need to be adapted and may differ depending on the manufactured nanomaterials considered and the endpoints that is trying to be read across. And of course, we have to mention that the grouping and read across is endpoint based. You cannot group nanomaterials for several endpoints at the same time, that you have to do the reading endpoint by endpoint. As an initial, as a linking with the previous workshop that took place several years ago in the United States regarding categorization. This is another methodology that can be used for simplifying the assessment of nanomaterials. Some of the genetic categories that were indicated in that workshop, like solubility shape and mode of based on solubility shape and mode of action, were considered as possible to be used as an initial step for the grouping of nanomaterials. And in any case, uncertainties need to be transparently addressed and for the justification for grouping and read across. As I mentioned before, the starting point is always the physical-chemical parameters that are the crucial starting points for the grouping. And we need some benchmark to define sameness or similarity between nanoforms. So something that is for the moment is still difficult because there has not been a systematic testing of the relationship between the physical-chemical properties and the effects that can be observed and produced by nanomaterials. And there is some limitation regarding the available, in particular, available test data, in particular regarding their quality. And for the moment, what can be done is to identify which physical-chemical properties are the ones that most matter regarding the effects on the possible effects of nanomaterials. And I was stressing again that the quality of the data is a critical issue, and the parameters of the physical-chemical parameters needs to be always monitored during the testing that is generating the data, and there is a need for harmonization and standardization of test methods, because this is one of the factors that so far has limited very much the usability and comparability of data in different studies and the development of appropriate grouping schemes. So some of the recommendations for further work that were concluded or were recommended by the experts in the meeting, there was to further work on the terminology used for grouping and indicators, not only the one for nanomaterials, but in general for the terminology used in the whole guidance document. Sometimes it's the use of categories, groups, etc. is not completely coherent, and sometimes can be conducive to misinterpretation. It was concluded. And of course, the nano-specific guidance has to be developed for nanomaterials, and as I said, mentioned before, with using case studies as example, and probably tier approaches are the best way to address the data needs and concerns for nanomaterials grouping. The OECD test guidelines need to continue being adapted to the specific cases of nanomaterials, and this is an activity that's already ongoing in collaboration between the Working Party on Manufacturing Nanomaterials and the test guideline programs indeed. And there is still the need to continue the international coordination and collaboration on research. That is one essential point regarding the reproducibility comparison of data between the different studies, and to be able to extrapolate data from one nanomaterials to others, to have harmonized dispersion protocols. That is one, the preparation of the test materials for testing, and also controlling the parameters during the testing is an essential factor to understand the behavior of nanomaterials and the possible extrapolation between nanoforms. And there is a need somehow to have harmonized reporting templates, as I said, to enhance comparability of results. And I just end here and recommend a number of further readings. A part of the report of the workshop, I would recommend some of the documents developed at the European Chemicals Alliance regarding the read-across assessment framework, in particular the one on nanomaterials, and some documents that were jointly prepared by the European Chemicals Alliance, the JRC, and our colleagues in RIBM. And a number of publications from our colleagues, led mostly by our colleagues of RIBM, in which we have been always as well collaboration, and suggest that you follow as well some projects, for instance, the results from the NanoRite project that finalized recently, and follow as well the project NanoCompute results, and in the future some projects that are currently ongoing or will start very soon. This is the EU-funded projects, NanoVac2, the project NanoCommons, and the project Gaseous that I mentioned in this slide. And if you will find a number of interesting information of the progress on grouping and building approach from nanomaterials. And I think that's from my side. That's all. And thank you for your attention.
Thank you very much, Juan, for that presentation. And I think it certainly highlights how, as we develop solutions, IATA solutions or defined approaches, or methods that we've used in the past, like read across, how we can think about the types of chemical code domains that they apply to, and what in this case certainly highlighted how there are similarities in using read across between nanomaterials and other chemicals, but there are then certain specificities that need to be applied in the methodologies, and I think it's something for us to think about as we develop other IATA methods and defined approaches. So I am going to give everyone, I'm going to say a few things. So while I'm saying a few things, you have a last opportunity to type in any questions to me. So I think, so as Masashi mentioned, one of the drivers for having this webinar was the IATA Case Studies Project meeting and helping that group identify where it might make the most sense to develop guidance. Also, what we have done as the OECD Secretariat, we sent out a questionnaire to sort of the regulatory risk assessment groups, related groups within the OECD, asking them to provide some input on where they think are the best areas to target either IATA development or defined approaches development in the future. And those were just due at the end of last week, so I don't have anything to share with you in terms of the results of those questionnaires. But it's something that we'll be, as a Secretariat, bringing to various discussions on IATA projects as we move forward. I think also there was an opportunity in looking across these projects to perhaps identify some synergies or opportunities for collaboration, and certainly not to avoid duplication. I mean, another aim in the Secretariat is that we have is to ensure good communication between all of these groups and to try and help facilitate that. So I hope that this workshop was able to help with building that communication. I just want to highlight, I think a couple of the high-level overarching comments or things that were made, but I guess there was a comment that we don't have an overarching framework for IATA. So do we need something like this that then the either guidance fits into? There's the angle of also how we think about different regulatory contexts or frameworks or even the different types of substances when trying to move to harmonization of IATA approaches, and this tension between prescriptive and flexible solutions. In the terms of defined approaches, is there a certain level of certainty that needs to be involved in identifying the information sources that are needed? There was the idea that we may need some type of reporting format for the outcome of defined approaches and maybe for IATA. So is there a way that we can best capture that prediction in terms of maybe some of the inconsistencies in some of the elements or the uncertainties in some of the elements and the confidence in the overall prediction? And then more broadly, how we can move to global acceptance of non-animal predictive methods. So I think in terms of, we just had one final comment coming in here, and it was, is it possible to work on a harmonized definition for IATA? And I think that's something that we tried to highlight in the first slide, I guess, just noting that it is a sort of a flexible framework that captures a lot of different types of elements, but really it is an integrated approach that tries to bring together various pieces of information for decision making. But I think if we decide that we want to work on some general framework for IATA or some type of general piece that more broad, I guess, at a higher level explains the concept, that's something that we can look at well articulating in there. And then there was another comment to that we could also look to identify the similarities of existing IATAs and work and look at the structure of those, and that might help to develop new IATAs as well. So those were a couple of the last comments. So just before we end, I'd really like to thank Masashi, who took over from Yuki in organizing the webinar. And this whole time we've also had Fabrizio helping with the IT coordination, and his colleague Mark also helped out with that. And then Nausicaa, who is not in the room right now, but helped a lot in organizing the workshops. I'd like to thank all of them. And finally, to thank all of the speakers who participated, and as well as for all of the participants for staying on the marathon WebEx. So thank you very much. I'm happy to say we didn't run late. We're actually ending early. So, but encourage you to bring any feedback on this in terms of the content or opportunities for synergies. Also in the future with the Secretariat members, or perhaps colleagues that you have in the other groups, and facilitate that also within countries. Okay, thank you very much, and we'll conclude here for today.